The broadcast is now starting. All attendees are in listen-only mode.
Welcome to everybody. I'm thinking that we're all just getting into the broadcast, so we'll give it just a few seconds while everybody joins, and then we're going to go ahead and get started. Very excited for today. We looking like I don't have normally I have the participants. All right, so welcome to the GAVRT Eclipse broadcast. We are very excited and have been anticipating this day for many, many months, like I'm sure all of you have. So we are excited to be your host. My name is Lisa Lamb, and
I'm Steve Levin, and we have people all over the country, and we have a bunch of different ways of looking at the sun to do science and have a little fun.
Yeah, so we are here at the GAVRT headquarters. Hopefully many of our GAVRT teachers and students are joining us in classrooms across the United States, and museums and informal learning centers, and in fields and homes all across the US. We are here in GAVRT headquarters in Apple Valley, California, and we have some very special partners kicking off this broadcast and several others who will be joining us throughout the broadcast. But we want to introduce them now. So first, let's start with Dr. Marin Anderson. Marin, where are you joining us from?
Hi, I'm so glad to be joining you guys. I'm joining from Austin, Texas. I'm here at the Austin Central Library under slightly cloudy skies that will hopefully clear up in the next couple hours.
Okay. And Marin is also one of our premier GAVRT scientists who works at NASA JPL, and as does Dr. Steve Levin. And then we also have Professor Bob Twiggs. Bob, tell us a little bit about where you're joining us from.
Well, I'm in Waco, Texas, so not too far from Austin. Just waiting here to see what happens. Melissa was staying here last night and took off for Meridian early this morning, so we're all just waiting here to see what's going to happen, and we're excited about this. This doesn't happen very often, and I've never been in one before, so what we've got a bunch of little dogs that are out in the yard. We're going to see what they do.
All right, and Bob is a newer partner to GAVRT. We're very excited about all the future work. So for all of our GAVRT teachers and participants out there, look forward to many more collaborations with GAVRT and the Twiggs Space Lab. So you'll get to learn a little bit more about what we're doing across this next few hours as we experience the eclipse together. So let's go ahead and kick off our slides, and Marin, Steve, and I are going to tag team those and talk to you guys a little bit about GAVRT and what we're observing today, and then kicking out to all of our partners who many of them are in totality. All right.
Yeah, so total solar eclipses are always really exciting, as I'm sure all of you out there are really excited right now. What you'll be seeing today, if you are viewing the sun, of course, safely with your eclipse glasses, I've got mine here to look at the sun, you'll see something that looks like the image on the left. So this is what the eclipse sun looks like at optical wavelengths, the wavelengths that you see with your own eyes. And what you're looking at in that image on the left is the sun getting covered up by the moon's limb and making that really beautiful crescent shape that we typically are more familiar with when we're talking about the moon. But during a solar eclipse, we get to see a crescent sun too. And the image on the right is what you would see if instead of your normal eyes, you had radio telescope eyes. So this is what the sun looks like at gigahertz frequencies. This is data that was actually collected with our GAVRT radio telescope during the last eclipse, during the annular eclipse in October. And it looks very similar to the optical image. You get that same crescent shape. You can see the moon's limb covering up the sun, but it also looks different. So the reason it looks different is because we're looking at different parts of the sun. In the optical image on the left, you were seeing the surface of the sun, or the photosphere. And in that radio image on the right, what you're actually looking at is the sun's outer atmosphere, or the corona. And the corona is really the star of the show, both in terms of the radio observations that we're going to take today that you guys are going to get to be a part of, and also in terms of what we see during a total solar eclipse. I'm in the path of totality here in Austin. Professor Twiggs is in the path of totality in Waco. And we're hoping that if the clouds clear, we'll get to see the corona with our own eyes in optical wavelengths as well.
Just keep it in this for a minute.
Okay.
All right. So I see we're on the next slide. So this is just to give viewers a sense of what physically is happening to give us a total solar eclipse and why they don't happen very frequently. So this is just a diagram showing the moon's orbit around the Earth. And you can see the video is hard for me to see because it's a bit gappy because of my cell service, but you'll see the sun on the left and you'll see the moon orbiting around the Earth. And one key thing that you'll note is that the plane of the moon's orbit is not exactly parallel with the Earth line, sun line. It looks like the moon's a little bit above sometimes that plane of that orbit and a little bit below sometimes that plane of that orbit. And that's basically why we don't get a total solar eclipse every month, because sometimes the moon's a little bit above the sun in the sky, and other times it's a little bit below the sun in the sky. And it's only when you get them lined up perfectly when you get a total solar eclipse or even a partial eclipse. The moon needs to be able to block out a chunk of the sun in the case of a partial eclipse, or completely block out the face of the sun in the case of a total solar eclipse. So we're lucky enough today that we're going to be seeing a total solar eclipse, hopefully if there's no clouds here in Texas. And if you're in the path of totality, regardless of if there's clouds, you'll get to experience nighttime during the middle of the day, which I think is pretty cool.
And I'll just point out it's kind of a cosmic coincidence that the moon is just the right size and distance so that it's pretty close to matching out the sun exactly. When we hit it just right, it can block out the entire sun, as seen from places on the Earth, which is what's happening now. But sometimes you get an eclipse where the moon's a little further away from the Earth at the time that it hits because the orbit's not perfectly circular, and you wind up with it not quite blocking the entire sun. You get what's called an annular eclipse. And of course, many more times, if you're either not in quite the right place on the Earth to see the shadow, or if it just didn't line up perfectly for anybody on the Earth to see the shadow fully, you can get a partial eclipse where it's only a little bit in front of the sun.
Yeah, and a fun fact that I always like to point out is that cosmic coincidence, as you called it, Steve, that's a cosmic coincidence in both space and time. So in about 600 million years from now, because the moon's getting further and further from the Earth in its orbit at the rate of about a few inches per year, kind of the same rate as your nails grow, it's getting further and further away. So 600 million years from now, there will no longer be any total solar eclipses. There will only be partial eclipses and annular eclipses. So now it's a really special moment in time.
Right.
Get the eclipses while you can.
Absolutely. And we're excited about it both for the spectacle and for the science. There's a lot of science that you can do when the moon goes in front of the sun, where you just have an opportunity to measure things you wouldn't otherwise be able to measure, both the effects here on the Earth and, of course, with the radio telescope. We're excited about it because the sharp edge of the moon coming across the radio image lets us see the image in a better way than we do on an ordinary day where we're just limited by how well our telescope can resolve things.
Indeed, yeah, that's an excellent point, Steve. If we go to the next slide, we'll be able to see that solar corona that we've been talking about. So this is what it looks like at optical wavelengths, again, the wavelengths that you would see with your own eye. If you're in the path of totality, during totality, this is what you would see if there's no clouds. You would see the moon covering up the surface of the sun, and what would come out would be this really beautiful thing that we call the corona. It's the outer atmosphere of the sun. It's basically a really hot soup of particles, what we call a plasma, that's millions of degrees hotter than the actual surface of the sun. And you can only see it during a total solar eclipse. We have space telescopes that study the sun and study the solar corona. But from the ground, the only time that you can access this part of the sun and do science studying this part of the sun is during a total solar eclipse. And I'm hoping that that's what I'm going to see in a couple hours here.
Yes. Hope so. Go ahead. Yep. So talk about where you can see that.
Yeah. Okay. So this is a map of totality. That's the path that the sun's shadow will trace across both Mexico, the US, and a little bit of Canada. I'm down sort of at the south of this path. I'm in Texas, along with Professor Twiggs. And totality should arrive sometime around 1:30 Central Time, so 11:30 Pacific. The path of totality is really quite narrow. It's only about just over 100 miles wide. And outside the path of totality, what you will see during an eclipse is just a partial eclipse. So the moon will block out part of the surface of the sun, but not completely cover it. So you'll be in a partial shadow. We call that region the penumbra, and you'll see a partial solar eclipse. And in the path of totality, you'll be in the part of the shadow we call the umbra, which is Latin for shadow, and you'll see the moon completely cover the surface of the sun. And that's when you'll experience all the cool aspects of a total solar eclipse. So in addition to being able to see the sun's corona, that faint outer atmosphere that's millions of degrees hotter than the surface of the sun, you'll also get to experience other sensory things, like it'll become as dark as nighttime during the full moon. If the skies are clear, you'll see the stars come out. I know that there's some planets that'll be in view if you have clear skies. You'll see potentially Venus and Jupiter, Saturn, as well as any other stars that might come out. And the animals will also be experiencing a shift that they think is suddenly a shift from daytime to nighttime. So you might hear more birds than you would typically hear in the middle of the day, maybe more insects. And you'll also feel a distinct temperature shift. So it'll become as much as 10 degrees cooler during the minutes of totality. And you'll maybe feel a breeze, it'll get cold. So a lot of really exciting sensory experiences, in addition to being able to see the corona, lots of ways you get to experience totality. I will mention that the reason this total solar eclipse is so exciting is because, well, one of many reasons is that this one is so accessible to such a huge fraction of the US. So more than 50% of the US population lives within about 250 miles of this path of totality. And if you are just outside the path of totality and you still have time to get into the path, I do encourage you to do that. If you are just outside that line of totality and you are seeing that you're going to get 99% coverage of the sun, you might think that's good enough. I don't need that last percent. But that last percent of the sun being visible means that it'll be 1,000 times brighter for you than someone that's inside the path of totality. And what that means is you won't get that shift from daytime to nighttime in the middle of the day. You won't get to see the corona, that faint, tenuous outer atmosphere of the sun. And it just won't be as cool as if you were in totality. So if you can safely get into totality, I encourage you. But if not, then you should stick with us here, because we'll give you a live stream view of what it looks like. And we'll be talking about all the cool science that you can do with your radio telescope during the eclipse.
So
let's talk about where everybody's joining us from today, because not all of us are fortunate enough to be in Texas. So we want to make sure that we're making the most of it. So do you want to talk about where we're coming from? And I have it.
Sure.
As well.
So of course, Marin and I and a few of the other people on the GAVRT project are from the Jet Propulsion Lab in Pasadena, California. Right now I'm sitting with Lisa here at the Lewis Center for Educational Research in the high desert in Apple Valley, California. If we keep moving along with the slides, you can see where people are in various places, including the radio telescope in Goldstone, California. So that's a key piece of information, because the radio telescope is going to see a partial eclipse. But what that means is we can look at the sun with the radio telescope, and as the moon moves across the sun, that sharp edge from the moon will let us see features on the sun that we might not have had the resolution to see without the moon going in front. You think of the way a camera phone picture works. If you have a really great camera that's got a whole lot of pixels, so whatever it is, say 10 million pixels, and you get a really high resolution sharp image, it doesn't look it looks different from if you have maybe an older phone that's only got 100,000 pixels and has a much blurrier image. But if you take that blurrier image that the radio telescope can see and move a sharp edge across it, then that sharp edge of the moon, when it blocks out different pieces of what we're seeing, lets us see higher resolution. We get a better idea of what we're looking at when we look at, in this case, an active region on the sun. You want to talk about some of the other places?
Yeah, let's talk about some of the other places. So also here at the Lewis Center in Apple Valley, California, we have our console. So we will be running live GAVRT observations throughout the eclipse to capture all of that amazing science that Steve was just talking about. So if we can turn on our camera over at the GAVRT console so they see what our mission control looks like. Do you guys want to introduce yourselves over there?
Yeah, my name is Ryan Dorsey. I'm the Director of Information Technology and Global Programs. Hi, I'm Velu Savi. I work at the JPL, and I'm leading this eclipse observation here.
Mikey, can you show the VNC?
I'm Nancy Kreiser Jenkins. I'm the lead operator, and I'm doing all the controlling of the antenna at this point to do the observations.
And so I tried to get attention because we're actually witnessing that phenomenon right now. We're looking at the limb of the sun, and you can see where my cursor is down on that nice little image of the sun. And right now the moon is moving across and that signal's going down.
Great.
The eclipse has started.
So if you think of that, if you look at that image of the sun we're seeing right there, that's a radio image taken a little while ago. And as Ryan mentioned, we're updating it constantly as the edge of the moon moves across and we gradually block out that image. Then because the edge of the moon is nice and sharp, we're getting more information about the details in the image as it gradually moves across and each part gets blocked out in succession, because we know where that edge of the moon is very precisely, and we can monitor how bright a signal we're getting as various pieces of it get taken away by the moon.
Okay, let's go back to our map. And I know that we have lots of classroom teachers joining us, not only from the Lewis Center. So the Lewis Center is excited that we have this tremendous collaboration with NASA JPL to run the GAVRT Radio Astronomy Project. But we also have two amazing schools, and I know a lot of our students at both of our schools are joining in. So we have the Academy for Academic Excellence, which is a TK through 12 charter school, public charter school, right here in Apple Valley, California. And then we have Norton Science. Oh, and we have some of our student Eclipse ambassadors ready to talk to you in just a moment. And we also have Norton Science and Language Academy in San Bernardino, California, which is also a TK through 11, but next year will be 12, free public charter school. So let's, without further ado, let's go to some of our student Eclipse ambassadors who will be partnering. The three that we have pictured here are in Apple Valley, California. You can see our skies are very clear in California. Too bad that we aren't in the path of totality because our weather conditions are perfect for that. They are going to be interfacing with student Eclipse ambassadors throughout Texas, throughout the path of totality. We're going to be doing some science together. Eclipse ambassadors, why don't you guys introduce yourselves? And oh, I see Texas is joining us, so we have some Eclipse ambassadors there. So let's go to our correspondents in the field from California, and then we'll kick it over to Texas. Go ahead, AAE.
Hi, we're the Solar Eclipse Ambassadors from Apple Valley. So I'm Natalie. I'm Caprice.
I'm Mosiah.
And yeah, we have our solar eclipse monitors here. So right now, we have pretty clear skies. So I'm reading about a 63 temperature and a 26% humidity. And then I'm reading a 76 temperature and a 29% humidity.
I'm reading with my Solar Eclipse Prime. I'm reading 73 degrees Fahrenheit and right around the same.
Okay.
How's it looking over there?
How's it looking in Texas, Melissa?
Hello, my name is Nick Mendez. I'm here with the NASA Seas internship program working with CSR. We're currently in Meridian, Texas. So we're on a ranch here and we have a bunch of people just all doing a ton of different research and experiments. Over here we have a few middle schoolers from Allen Academy working on their experiments. Behind us we have a few NASA Seas interns. We're setting up different sensors that are going to collect data so we could share to students to California that might not be able to see the eclipse. But we're about to start reaching the point when the moon starts covering the sun. Our glasses are ready. We're excited to go.
We are excited to experience this vicariously through you. But I think that this brings, look at the sky. The sun is coming out. We're so excited. We need to transport some of our very blue sky. So I think that one of the things that Maria and Steve and I really wanted to talk to you about throughout this broadcast is why it's so important to use so many tools during this very special event. So, you know, GAVRT, we're radio astronomy, so we've mentioned a little bit about how that works and why it's so special.
Yeah, I'll just point out that a couple of things. One, of course, we can see through the clouds with the radio, so that helps. Even if it were cloudy in here in California today, we'd still get valuable measurements. But also, we see a different part of the sun. Remember what Marin pointed out, when you see with your eyes, normally when the main part of the sun isn't blocked, you see the photosphere and you see this really bright sun that makes it hard to see anything else on the sun. With the radio telescope, different frequencies see different depths into the corona. So we can see parts of the sun with each of our channels that are different heights relative to the edge of the sun, if you will. And therefore, we can map what happens down on the surface where, for example, there might be a sunspot, to what shows up way out in the outer corona, where the magnetic field has carried that hot material from the sunspot up and is affecting the corona. Likewise, if you measure on the ground with the different instruments the students were talking about, you learn different things about the effect of the eclipse on the conditions here on the Earth, on the weather, the local weather. And if you're paying attention to what the animals do, then you can see something about the biology of that and how the animals are affected by what's going on, and correlate that with the different things we're measuring. So we learn about a wide range of things. We're not only learning about the sun, we're learning about its impact on our environment and on the life that's there. And I'm probably leaving some stuff out. Marin, if you've got anything you want to add to that, or any of our students in Texas who are doing things. I think somebody has a weather balloon you guys are going to use.
Aton from University of Texas is going to be using a weather balloon.
Did I leave out anything crucial on the science somebody wants to mention?
No, that was great, Steve. Maybe I'll mention that one of the reasons we're so excited to observe with GAVRT with our radio telescope during the eclipse is, as you mentioned, we get really high angular resolution, which means we can see things that we wouldn't normally be able to see without the eclipse happening. And those active regions that we're targeting are regions where we get really strong concentrations of magnetic field lines in the sun. And that's exactly what we're probing with our radio telescope. We'll get to see what those magnetic field lines are doing, what heights in the corona we're getting radio emission from, and as you said, trace structure in the corona that we wouldn't otherwise be able to see if we weren't observing during an eclipse.
So before we talk about safety, I'm just wondering, Melissa, do you guys have something you want to share, or another student out there in the field you want to introduce us to?
Yes, we were preparing something to tell you about, and then we heard the comments about the balloons. We have multiple balloon missions going on, and I'm going to have a C student tell you about it. So say your name.
Okay.
Hi, my name's Ella Brochu. I'm from Alabama, and I'm the group of interns. So right now we're basically setting up hardware to study the temperature, humidity, and so we're doing some on the ground and then some tethered balloons as well, some free-flying balloons, just to kind of see the differences between them.
That's going to be really great, and that's going to work out really well with our eclipse monitors that our students built. So they're doing them on the ground, and then we can compare that to the weather balloons.
We have their monitors here.
Yeah.
Right.
So so that's what they're making the connection right now. So let me come over.
Yeah.
These monitors and the GAVRT team, these this Lisa Lamb, Dr. Lamb, she led this with these students.
This is so cool.
So we have a lot of like organic, natural partnerships that have been happening, right, Dr. Lamb?
Yes.
That's right.
Yes.
They have their signature just right over here. It's really cool being able to show off their work and what they do.
Nice.
I'm just really excited here that we're able to help them with an experiment that they wouldn't be able to do otherwise just because of their location.
Right.
It makes me proud being here, working on the balloon, sending everything up.
And that's part of the process of science. Science is a very international kind of business, and it's not at all unusual for scientists on one mission or another to have something you're doing locally and then people you partner with in another location where it works better or have different equipment or things like that. I think it's also worth noting the value of the science here for the weather stuff. Getting that abrupt change as passes in front of the sun, a different take on weather than you get during the much slower process of sunrise and sunset during a normal day.
Mm-hmm.
So for all of our Lewis Center students who are joining here in California, I want you to know that those eclipse monitors that they're showing there and those boxes, those were built here at the Lewis Center by our students, and we sent them to the field across Texas. And so that's so exciting to see that you guys have the Eclipse monitors there and will be taking our tools. So I know not all of our students were involved. We have nearly 3,000 students in our Lewis Center schools and classes, but we did have 10 of you involved in building these Eclipse monitors. And then Messiah, Natalie, and Caprice are representing you here, monitoring their own outside. So, okay.
That is so exciting. So the Eclipse monitors were actually started their development in the C's intern program last summer. So it was just an iteration of remote sensing.
Mm-hmm.
So you want to tell about, he's holding a device from your students as well as one of ours.
So I don't know if you can see it, but we have here some of the devices here with a lot of different sensors. And this one in the tiny box, we're actually hooking up to the balloon to set up at like
Nice.
Yeah.
of height 100 feet just to get different sets of data. But I mean, everything has been put together so well. We're just setting up the balloon right now.
Good job from your team.
Good job, guys. That's terrific. All right. We before we go over to the High Desert Astronomical Society over at the Apple Valley Center for Innovation, we're taking some doing some observations there as well, both for the High Desert community and for Apple Valley schools. Before we do that, Marin, do we want to talk about how to safely view the eclipse?
Yeah, let's do it. I was just safely viewing the eclipse. It just started from Texas. So I got to see an eclipse sun. That was really exciting. Yeah, so we always want to think about safety when we're looking at the sun, especially during an eclipse. So if you're looking at the sun, you want to make sure that you've got your specialty eclipse glasses or your solar viewers, as these folks here in this picture are looking at the sun. At any time, either during an eclipse or at any normal time of day, if you look at the sun, you want to make sure you're looking through one of these solar glasses, because you can do permanent damage to your retina, to your eyes, if you're not looking through one of these safety glasses. So keep that in mind. If you're in the path of totality, the only exception to that rule is take off your eclipse glasses during totality, because that's the only way that you're going to see that corona, that outer atmosphere of the sun, which is the really special part of seeing a total solar eclipse. But if you're not in totality, and if you are in the path of totality, but it's not one of those few minutes of totality, make sure that you're wearing your eclipse glasses when you look at the sun. Steve, do you have anything to add to that safety message?
I think you covered it all. The important point I wanted to make sure everybody heard is you hear about safety looking at the sun during an eclipse, but it's true all the time. Don't look at the sun without safety glasses, whether it's an eclipse or not, unless you happen to be in the path of totality during totality. That's the only time it's safe to look at the sun without eclipse glasses.
Yeah. And the flip side of that is, if you've got a pair of these for the eclipse, might as well use them after the eclipse is over, and on a random day of the week when the sun's out, I encourage you to look at the sun through them.
And if you don't have the glasses and you're outside right now watching this, or you're inside and you want to go outside and see it, don't despair, because there's another really great way to see what's going on with the eclipse and the sun, where you don't have to look directly at the sun at all. If you just let the sun shine through a tiny hole, like a pinhole, or make a hole with your hands, or even look at the shadow from a tree with a lot of leaves, you'll notice that the little dots of light on the ground, which would ordinarily be circular, the shape of the sun, will start looking like little crescents as the sun turns into a crescent. So it's another really fun way to look at the eclipse. I've seen a lot of pictures from previous eclipses. It's a nice way to get a picture that shows what it looks like, and people play games. You know, you go out with something that makes lots of different holes of different sizes and see which one gives you the best image. Yeah. It's really cool.
Yeah, it's cool. Should we mention about taking pictures? Because I know a lot of folks might be tempted to record the eclipse and try to get it. Maybe we should talk a little bit about that.
Yeah, depending on your camera might need glasses, eclipse glasses also. Yeah. If you just point your camera at the sun, some cameras can handle that, and many cameras would be ruined. So don't point your camera at the sun unless you're really sure you understand whether it's safe to do so for your camera.
And then also I would recommend just leaving it to the professionals and enjoying the eclipse.
Right.
Don't miss out on experiencing the event, whether it's partial like here in California or you're in the path, lucky enough to be in the path of totality. Let's experience it. We know NASA's getting all kinds of images for us, so let them do it.
Speaking of that, should
Good
we
advice.
look at the NASA?
Yeah. Should we go over to that? And I think we're gonna try to get HIDAS linked up here in just a minute. So let's look at the NASA feed. We'll go over to that for a second, and then we'll come back and introduce HIDAS.
I think we're okay. So on NASA Live, you can see from various places, and you can see in the upper left, that's from Mexico, and they're showing.
You can turn on sound.
There's quite a bit more progress because, oh, here we go.
We had NASA's Marshall Space Flight Center, the Arkansas Air National Guard, the U.S. Space and Rocket Center, and even the Paris Observatory joining us all the way from France. Now, during that moment of totality, Arkansas will experience from 94 to 100% obscurity from the sun, and we'll have 4 minutes and 12 seconds to really soak in that fantastic cosmic event. Now, until that moment, of course, we are telling the residents to stay safe, keep those solar eclipse glasses on. But now let's go from Arkansas to Illinois. Blair Allen, how are everything looking for you?
Jasmine, we're super excited here because crowds are filing into the stadium. But the main story here is the weather. Everything looks absolutely good and clear for totality today. We're very excited. We're just hoping, just like 2017, a little cloud doesn't come in and obscure things. But I tell you what, there's been a total solar eclipse here in 2017. Observation did not stop at SIU. Joining us now are 2 SIU students who actually did some observing. This is Callie and Paige. Now, Callie, I know that you guys went to Australia in 2023, and you observed the totality using an interesting technique. Can you tell us about that?
Yeah, so when we were in Australia, we used a sun funnel to view it. And what it does is it projects basically what the telescope is seeing onto a film. And so sun funnel is just basically a funnel and represents system. And it just projects the sun, and we actually captured a picture of totality as that eclipse was happening.
And it's pretty cool because it allows other people, instead of having to go through the eye gates, you can see it. Pretty impressive. Now, Paige, you guys are going to do some observation today. What did you set up for here in Carbondale today?
Yes, so we have 2 telescopes set up with the sun funnels for viewing for a select view of the public. And right now we're pointed at the sun, and we're excited to see totality.
Now, what are your odds on good weather?
We should pull away
It's looking pretty good. I'm excited.
Isn't that great? I'm so excited. I tell you what, one final question, because I know you're experts with solar safety, but Team Earth, Sun, or Moon?
We're both Team Moon.
Team Moon, Team Sun. I tell you, that's the best you're going to get, but we're all pro Eclipse. Back to you, Tahira.
Let's go Team Moon. So, as you can see, folks, we've got a lot of exciting things in store all across this country, and that was only half of it. You're going to meet three more of our locations later on in the show. Now, as you know, we've got a ton of questions coming in online right now from our viewers. Yeah. How do you feel about some Q&A? Let's answer them. Okay, perfect. Let's do it. So, our first question is from
Sorry. Texting. Okay, let's go ahead and go back to it.
You can help now.
All right. So coming on back, let's go back to our next. Let's check in with HIDAS really quick. Can we do that? And then we'll go back to our sites. Okay. Do we have Erica on? If not, we'll go back to our sites. No, that's okay. Coordinating all over the country. There's going to be some delays in that. If you guys see me on my cell phone, that is only just coordinating who's coming up next. Okay. All right. So let's go with, let's go to our next slide. Let's talk a little bit more about GAVRT specifically. Is this one to Marin?
I don't know.
To Steve?
Either way. Marin, you want to talk
Steve,
about it?
Steve, why don't you go ahead?
Okay.
Yeah, you go ahead.
GAVRT is the Goldstone Apple Valley Radio Telescope project, and what we do is we do science with a NASA radio telescope, a 34-meter dish, so that's a large radio telescope, and we do it with citizen scientists, with students and other citizen scientists all over the country. One of our campaigns is the Solar Patrol, where we are using the radio telescope to study the sun, and of course we're taking advantage of this great opportunity during the eclipse to do that. You can see an image of the radio telescope there on the right. I'm trying to remember if this one was a video or not. What we do ordinarily is make a map of the sun repeatedly with the radio telescope. So you can scan it back and forth and get an image of the sun with the resolution determined by how small a spot on the sky the radio telescope can see. But during the eclipse, we take advantage of that sharp edge of the moon to get better resolution. And the idea is to pick one of the active regions on the sun, so a bright spot on the sun, stare at that with the radio telescope, and then as the edge of the moon comes across, we get a much better idea of what's going on with that active region than we could if we didn't have the edge of the moon coming across. I wonder if we can bring it to observations now and show us.
I was going to say we have a question.
Okay, great. Happy to have questions.
All right, so question from Chase. If an eclipse is when the moon covers a lot of the sun, why is it wrong for us to be looking at it?
So Chase was asking, I don't know if you all heard that live, but he was asking, if the moon is covering a big part of the sun anyway, why is it not safe to look at it during the eclipse? And the problem is the sun is so bright that even a tiny percentage of the brightness from the sun is still too bright for your eyes to handle it and can do damage. Not only that, but because when you ordinarily during the normal course of the day, people don't go blind from looking at the sun because as soon as you try to, it's painful and you don't look. If you dial that brightness down, you can get a very dangerous situation where it's not quite painful enough to stop you from trying, and it's still too bright and will damage your eyes. So it's particularly important during an eclipse to pay attention and not look at the sun. During the course of a normal day, you shouldn't look at the sun either, but that probably won't arise because if you get close to the sun, it's awfully bright and it's going to naturally turn you away from it all by itself.
Okay, did we have other questions?
Yeah, that was great, Steve. Oh, I just wanted to add that in addition to Steve's excellent explanation as to why it's dangerous to look at the sun during the eclipse, it's even worse during the eclipse because your eyes, in order to adjust to it getting darker in the sky because the sun's covered up, your eyes dilate. So you are letting in more sunlight and therefore causing even more potential damage to your eye.
Right.
That makes sense.
So I'd love to see if we can get a look at what the radio telescope is doing right now. So we're in the middle of making an image of the sun. The radio telescope is scanning back and forth. So if you look at that picture in the lower right, see a scan line going across right now. We've got a couple of active regions on the sun. There's that big bright one in the middle, and there's another one to the left of it. And we'll be choosing one of those active regions to stare at with the telescope while we let the moon come across so that we can measure how its brightness rises and falls as we start with just looking at it directly. Then as the moon's shadow gradually comes across it, we'll get a drop in brightness. And then when it comes back out again, we'll see it again. So images like this during the eclipse are mainly so that we can pick which of those active regions is the best one to do our observations with. If we wait you'll see another scan line come in a moment. This is more what a typical day would look like if you're doing solar patrol with us using the radio telescope. You'll see images like this appear. And of course, we can also do some work analyzing those images. It's not enough to collect the data. You actually have to process it and do something meaningful with it.
Okay.
Anybody want to add anything to that?
I think Ryan's ready to add something.
I'm ready to add another question.
Okay.
So Mrs. Covarrubias in Salud, California Her students had a question about this slide and wants to know why the Earth looks so small.
I think it was this slide.
This slide.
Right.
This slide.
And the answer is because it is so small. So in order to hold the image of the moon's orbit in this picture, you have to shrink the scale enough to be able to see the orbit of the moon. And when you do that, the size of the Earth is, I think, actually to scale here, right, Marin? It's quite small.
Yeah.
The moon is 240,000 miles away, if I remember correctly. That's a pretty good distance. And on the grand scheme of things and the size of the solar system, the Earth is tiny compared to the size of the sun, tiny compared to most of the other planets. Jupiter, for example, is big enough to fit 1,000 Earths inside it, fit 1,000 Jupiters inside the sun. So it looks small because it is.
Okay. I see we've got some kiddos at Texas ready to talk to us. What's going on over there, Melissa?
Oops.
Hi.
Sorry.
So I'm Kendall Hanover. I am a senior at Allen Academy, and we are here in Meridian, Texas, gathering data right now. Our group is focusing on like sounds that animals are making before, during, and after the eclipse to see if the darkness affects them at all. We're also taking atmospheric data. We're looking at barometric pressure, humidity, temperature, and other stuff, and UV radiation levels, just to see how that changes around the time of the eclipse. So we're gathering that data right now.
All right, you want to come up?
Can't wait to hear what
Hi,
you
my
find.
name is Owen. I do most of the programming for like robots and data analysis. For example, we're recording wildlife right now. So I do like I graph that stuff and get data on it. And I've also helped program some of the robots we are using. And Joe here is helping me deploy them.
I've built all of the robots that Owen has coded. I'm working on the crawler. It moves around and picks up solar radiation.
Yeah.
Mm-hmm.
Good.
Hi, I'm Anna. I'm in ninth grade. I'm one of the other team leads. And I'm in charge of mainly scheduling and then also humidity, temperature, and barometric pressure. So.
Terrific. Getting all kinds of data. All kinds of data on that ranch. More data than that ranch has probably ever seen. Okay. So
We have one more question, but we have something exciting right now. You can see the moon showing up in our raster scan.
Oh, yeah.
Oh.
All right, so see the radio image over on the lower right? You can see the shadow of the moon starting to approach those hot spots and, of course, block out part of the sun.
Right.
Sorry, I said shadow of the moon. It looks like a shadow. It's really the shadow lens here on the Earth. It's the moon getting in between us and the sun.
All right. I like that question about which team are you on? Team Moon for the win.
I think Marin wanted to say something.
One thing I wanted to add for this image is that you'll see that really bright, looks like a red spot in this particular graph, which is an active region that we're targeting as part of our GAVRT observations. And if you recall back to the live stream that we were showing earlier from Mazatlan, showing the live optical video footage of the eclipse happening there, you might have noticed a dark spot, really hard to see, but sort of in the middle of the sun. And it was co-located with this red spot that we see in our radio data. What we're looking at with our radio telescope is the active region. And what you were seeing, if you saw that dark spot in the Mazatlan footage, that's a sunspot that's associated with that active region. So this is, in our radio map, the emission coming from that active region up in the outer atmosphere of the sun, in the corona. And what you were seeing in the live stream from Mazatlan was an optical image of the surface of the sun, where the sunspot is located below that active region. So the magnetic fields that are threading up through that sunspot on the surface of the sun are the same magnetic fields that are producing the radio emission that we detect in the corona of the atmosphere of the sun in our radio data observations. I just wanted to point that out. I thought it was cool that we could see the sunspot.
Yeah, that is cool.
It's also really interesting to note that because the sunspot is not quite as hot as the sun around it, it looks darker than the rest of the sun. If you had it all by itself, it would still be glowing really bright, but compared to the rest of the sun, it's not quite as bright. And in the radio, those same regions that we're seeing where we're seeing them a little bit up from that, not seeing the same place in the sun, they're actually hotter rather than colder. They're brighter in the radio rather than colder the way you would see it, darker the way you would see it with your eyes. That's just another indication of the value of doing the measurements with every kind of instrument you can get your hands on and every wavelength you're able to measure.
Got another question for you guys. Miss Elgohari is watching with her class in Barstow. During an eclipse, why does it get colder if the sun is still up?
So basically it's colder for the same reason that if you're out on a hot sunny day and it's too hot, you want to stand in the shade. So what's going on is you're in the shadow of the moon and it's cooler in the shadows. Less sunlight is getting to you. The bright sun is still heating up the rest of the earth, but the little patch of ground that you're standing on is in the shadows, and so it cools off. And Marin, you're probably experiencing a little bit of that right now, right? You're not quite in the full shadow, but is it getting a little cooler? I think we lost your sound.
Oh, can you hear me now?
Now I can, yeah.
All right, yes. Yeah, it is getting cooler, although in our case here in Austin, I think it's more just because we have a lot more cloud cover. So in our case, there's a lot of shadow provided both by the moon itself and also predominantly by the clouds. So it's getting cooler here. The wind's picking up, but I think that's more weather-based than necessarily shadow of the moon based.
Right. So an experiment you can do for yourself to see that when there's not an eclipse going on is if you've got a piece of ground, usually works better if it's concrete or something like that, hard surface, that's partly in sunlight and partly in shade, just put your hand down on the ground in the sunshine part and put it a few inches into the shade, and you can definitely feel the difference in temperature. It's just cooler in the shade. You're getting less sunlight to heat it up. During the day, that shadow moves really slowly because it's the Earth's rotation that's driving it around, and it takes us 24 hours to rotate once. So the ground is still pretty heated by the edge of the shadow because it's been in the sunlight just a short time before. And you can feel that difference in time by feeling how close to the edge of the shadow you are. During an eclipse, happening to all the area around you relatively quickly because the moon's casting a shadow in that area relatively quickly. So you can feel it overall without having to walk in and out of the shade.
Okay, should we go to our next slides and then we'll come back maybe and check in with our students and maybe we'll get HIDAS on. They're getting some great images from the observatory. Okay.
So I guess this one is to talk about the Deep Space Network. Our radio telescope that we use for GAVRT is in Goldstone, California, on the grounds of NASA's Goldstone station. There are 3 complexes for NASA's Deep Space Network. These are radio telescopes that are primarily used to communicate with spacecraft. So we send a spacecraft off to Mars or Jupiter or Saturn or something, and we want to be able to talk to it. We use radio to do that in general. And because it could be anywhere in the sky, it's not enough to have your radio telescope in only one spot. If we did that, then for half the time, whatever we're trying to talk to would be below the horizon. So we have 3 of them. The Deep Space Network is 3 complexes, one in California, one in Australia, and one in Spain. As you can see in the image, if you do that, that means any place in the sky, one of those radio telescopes can see it. The radio telescope we use for GAVRT was essentially retired from the Deep Space Network and given to us. Obviously, we don't move it. It's a very large building all by itself. I think it's 12 stories tall is the equivalent, something like that. But we connect to it remotely and allow the world to connect to it remotely to do science, which is what we're doing today.
And it's totally free and open to all and very easy to connect to, and you do not have to be a radio astronomer if you want to join GAVRT. So we have them already on the team, so we don't need to be them as educators. I myself am a classroom teacher, now in administration, and even I could do a GAVRT session, so no specialized training needed.
Right. Everybody is welcome to contact us, particularly teachers. We're really excited about getting teachers involved with GAVRT. We have a long history of that, and of course, we get more people involved when you bring your entire classroom rather than a few people here and there. So anybody who's out there, if you're a classroom teacher and you're not familiar with GAVRT, take a look. You can sign up and meet educational goals at the same time we're meeting scientific goals.
So keep the questions coming for us too.
Oh, yes,
Yeah.
please keep the questions coming and let us know where you're joining from, who you're with, that kind of thing, so that we can shout out and enjoy this experience all together. So let's do a couple more and then we'll head on out to our Eclipse ambassadors outside.
So I see we've got the 4 different frequencies up now, GAVRT maps. These are our maps that were not taken today, but they show you the sun as seen in 4 different channels. And we're looking at 4 different depths through the corona, so you can see that the image looks different, and that helps us a lot. I don't know if, Marin, if you want to say a few words about that. That's sort of your baby, right?
Yeah, happy to talk about this. Sorry, I was getting distracted. Every time the sun comes out here, the crowd cheers and claps, and then I have to take a look at the sun.
Yes.
So yeah, what we're looking at here, what we're looking at here, as Steve mentioned, so this is, if you participate in GAVRT Solar Patrol, this is the kind of data that you would collect yourself and the kind of data that you would analyze. So these are maps of the sun, not taken today, as Steve mentioned, taken last year, actually, as part of October's annular eclipse. These are 4 simultaneous maps of the sun taken at 4 different radio frequencies, spanning from about 3.5 gigahertz up to about 13 gigahertz. And the reason that we want to look at the sun at simultaneous frequencies is because it gives us different information. And in this case, it's allowing us to see different layers of the sun's corona, but essentially probing down to different depths. At the lower end of the frequency spectrum, down towards 3.5 gigahertz, which is the leftmost map there, you're seeing up higher in the corona. And then at the higher frequency end of the spectrum, towards the 13 gigahertz maps on the far right, you're seeing down into lower depths. So you're seeing closer and closer towards the sun's surface. In each of these maps, you can see bright features. The brightest one is the feature that you see towards the left of the sun's surface. It's colored here in a red and a white, and that just corresponds to how bright it is. So the map is color coded according to something that we call the brightness temperature, but you can think of it just as how bright the sun is in the corona. And the brightest regions are the ones that are in red and that hot white color. And that just corresponds to seeing a lot of really bright radio emission from that active region that we're seeing on the left. And again, an active region is a location in the outer atmosphere of the sun where you have a really strong concentration of very strong magnetic fields. And those magnetic fields produce really bright radio emission. And by looking at the sun and those active regions at multiple radio frequencies, we can see different heights in the corona, and we can see, we can reveal the structure of the magnetic field in those active regions. Is there anything I left out of that, Steve?
Nope. The way I think of it is these concentrated magnetic fields that Marin mentioned are connecting the sunspot down on the surface of the sun with active regions and radio emission out in the corona up high from the sun. And we're getting kind of a 3D view by looking with 4 different wavelengths.
Yeah, that's a great way to put it. A 3D view, not just seeing the surface of the sun or the corona and its topography in 2-dimensional space, but yeah, getting that in-depth 3-dimensional look as well.
Okay.
And then I'll add that we would love for all of you participants watching now to get involved in GAVRT Solar Patrol, and you can scan this QR code and get to our website and see how to contact us, what Solar Patrol is all about, and get involved. Pass it off to you, Lisa.
Today is all about the sun, but we have 3 other science campaigns as well, and you can learn about those on that same GAVRT website.
Okay. Should we see if Erica Pagano over at the High Desert Astronomical Society can unmute and join us and tell us what it's looking like at the observatory here in California.
It is a beautiful day out here in California.
Let me see her camera. Can you turn on your camera, Erica?
See if I can turn the camera on. There I am. Hi.
There she is.
I had to run inside and join from the computer inside because it wasn't working outside for some reason. But here I am. Hello.
Hi.
Hi. Tell us what's going on over there.
We have so many citizens out here. We have general open to the public viewing right now. We also have a Mariana Elementary School. The kindergartners are out here, all enjoying the eclipse out here at the Luz Observatory at the Apple Valley Center for Innovation. It's really fun hearing all of the excited squeals coming down the stairwell from the telescope upstairs.
Terrific, terrific. Okay, well, keep us posted, Erica. Check in with us as you guys start to see some things. Feel free to go on out and show us all of those excited kindergartners and public, kind of, let me say, citizen sciences for K to grade. So we want to see everybody.
Yes.
Okay. All
Thank
right.
you.
We have some more questions.
Let's take some questions and then we'll get ready for our student ambassadors. And we're also trying to connect with astronaut Dan Tanney, who is in Pennsylvania. So he's out there on the shore and trying to get cell reception for us. So stay tuned. We're trying to get him to join the broadcast as well. But let's take some questions.
Nathan Rivera was asking, how can I see the eclipse without glasses?
Okay.
Oh, yes, let's talk about that.
First thing is, don't try to look directly at the sun if you don't have eclipse glasses to protect your eyes. However, when you see the shadow on the of anything on the ground, the shadow you are seeing is made by sunlight. So if you take a small hole, you can just make a little hole in a piece of paper and hold it up and look at the shadow. The bright spot you get in the center of that shadow on the ground is shaped like the sun, which means that as the moon gets in front of the sun, you're going to start seeing, instead of a circle, you're going to start seeing a crescent shape. Not only that, but if you just go look around you in nature, you'll probably find a bunch of examples of that you hadn't even noticed before. The usual one that people talk about is when sunlight filters through the leaves on a tree, the shadows that make on the ground have all these little bright spots in them. And each of those bright spots is a little image of the sun. So you can actually see the crescent shape by doing that. There's other things you can do. You can use, a magnifying glass to make an image of the sun or things like that. But I would say the eclipse is going on. You don't want to miss it while you go try to gather equipment. If you're just thinking about this right now and you haven't done anything else to prepare, you don't really need to. Go outside with anything that's got a little tiny hole in it and look at the shadow of the hole and you will see the eclipse happening. You'll see the crescent. And Marin, I don't know if you want to say anything about that. You're actually out there in the sunshine right now. You've probably seen some of that going on, right?
Yeah, exactly. You can probably see the sun shining on me now. It's very exciting. The sun's finally coming out here. While you were talking, Steve, I was looking at all of the shadows that the trees are making to see if I could see any little crescent suns in the shadow of the leaves. I'm not seeing any right now. I don't think it's bright enough, but I did come equipped. I can pull it out here. I came equipped with the pinhole camera that my parents made during our live stream last year. I don't know if you can see it very well, but there's a tiny hole right there on the back of this card. Yep. And I'm going to go, right after I finish talking to you right now, I'm going to go stick it out in the sunlight and see if I can see the image of the eclipsed sun through my little pinhole camera.
Cool.
And I think that all of our students, if you could even just Google really quick pinhole camera, but it's very simple to make one. So that's something to do on the fly right now. So any of our Lewis Center students, teachers, if you want to take your kids outside, go ahead and whip up some pinhole cameras and you can observe safely.
You can even just put your hands together like this and hold them out there and look at the shadow and you'll probably be able to make it work.
Okay. While Marin is doing that, do we want to see how our California Eclipse ambassadors, how are you doing? How are your monitors? What are you seeing?
Oh, hi, we're checking back in from Apple Valley. So currently my temperature actually decreased from 79 to 62, and then my humidity went from 29 to 26.
Yeah, I'm getting about the same. I went down from 74 to 60 right now with my degrees, and I went up in my humidity from around 24 to 31. And I'm definitely feeling the temperature difference with the breeze that's happening right now.
Yeah, my monitor is reading 73 degrees Fahrenheit and 19% humidity. So it went down a little bit.
Very interesting, right? What do you guys see with your glasses? Are you seeing the beginning of the eclipse? Don't look up.
Yeah.
Yes.
You don't have them on.
Yeah, there's a lot of coverage with the moon right now. It's really cool being able to be out here and seeing it slowly get more and more coverage with the moon. It's really awesome.
Yep, we're about 30 minutes away from maximum, so we're excited to see that.
Okay,
Definitely.
make sure we view safely. Great job, guys. Interesting to see what a difference, even though in California we're not anywhere close to totality, what a difference that your monitors are catching.
Yeah, I think there's also an interesting thing there about scientific measurements to notice, and that is the three monitors don't all read exactly the same.
Oh, yeah.
And you expect that because you got uncertainty in your measurements, both from whatever's doing the monitoring and from whatever kind of enclosure it's in or where it's located and so forth. But the differences between now and a little while ago are much more consistent from one monitor to the next. And that also is fairly common. It's quite common when you're doing a science experiment or you're doing a measurement to try to figure out a way to measure what you want as a difference rather than as an absolute number, because whatever the effects are that are causing the different monitors to be different from each other probably aren't changing as much as the change you're getting from the eclipse. So the measurement of the difference between now and half an hour ago is more precise than the absolute measurement.
Interesting.
We do that with the radio telescope all the time. We're trying to measure the brightness of something. We typically don't just point the radio telescope at it and stare. We point, say, at Jupiter, we point at Jupiter, and then we point away from Jupiter. We go back to Jupiter and point away from Jupiter. So we can measure the difference because that's much more precise than trying to just measure the absolute brightness.
Let's make sure we're noting the time and what your measurements are too, so that when we reconnect with your Eclipse monitors that are in Texas and all the students who are monitoring them, that we can check it out and compare where we are at of the coverage of the moon. Okay, all right, let's go back to our slides. Yeah?
Sure.
Unless we have more questions. Oh, let's take more questions.
All right, Miss Rito's math class.
Hi, Miss Rito's math class from Norton.
One of her students, Stephanie, what are some of the aftermaths from an eclipse?
The
So
aftermaths.
lingering effects?
I
think that's
It's a good question, and I'm not sure I know the answer.
So good, you stumped Steve. Little alliteration.
Well, first, let me see if Marin knows the answer. Do you have any comment on that?
Aftermath.
Can you guys repeat the question?
He's asking about after the eclipse. When the eclipse is over, are there any kind of aftermath, lasting effects, or things that change that don't go away as quickly?
Yeah, that's a great question. The only thing that I can think of is if we're thinking about the Earth's ionosphere. So if you imagine the Earth has their atmosphere, and then above that, there's a layer of what we call plasma. So instead of molecules and atoms like what we breathe and what's in the atmosphere, it's particles that have been separated. So it's no longer a molecule or an atom, it's just an electron in the nucleus. A soup of that exists around the Earth called the ionosphere. And how dense it is, how many of those electrons and nuclei you have in the ionosphere is a function of how much sunlight you're getting. So when the sun's shining down and hitting the ionosphere, you get a lot of separation of molecules and atoms from their component parts, and you get a lot of electrons and a lot of nuclei. When the sun stops shining, those things recombine and you create more molecules and atoms than you have plasma particles. And so I think maybe after the eclipse is over, while the eclipse is happening and you're not getting a lot of sunlight impacting the ionosphere in the path of totality, you would have a lot of those particles recombining, and you would get a less dense ionosphere. And then as the eclipse ends, it takes a while for those particles to turn back into a plasma once the sun starts shining again. So there's a bit of a delay there. And one of the things that scientists are studying for this total solar eclipse in the US is measuring the effect on the ionosphere of the eclipse in the path of totality. So that's the only thing I can think of, but that's a really cool question.
Good job, Stephanie.
As you're talking about it, made me realize something else. We ought to ask our friends in Texas, the students who are doing all the measurements and keeping track of the animals, whether it takes a while for the animals to recover. After this is over, I'd be really interested to see in their data if some of the activity of the animals changed during the eclipse. How long did it take to change back?
So one of them, it sounded like, was tasked to specifically track animals. So we'll have to go back to him when Melissa joins again. All right. Do we want to go back? Oh, Melissa, there you are. Wait, you're muted.
Looks, I can see a balloon in the background.
I see a balloon and I see breaks in the clouds.
Yep.
I still don't hear you, Melissa, but we see you. Oh, look at it go.
So they're launching a weather balloon.
Launching weather balloons.
And I guess if we don't hear Melissa, I'll just point out that you put weather instruments on a balloon because the weather can be significantly different between the ground and even as close as a few hundred meters up. I believe they've got at least one balloon there that's going to get up to something like 100,000 feet. So you'll definitely get different measurements up there. And all the distance in between, it's really interesting to find out how things change due to the eclipse. So I imagine you've got some other balloons that are at different heights, probably not so easy to get intermediate heights between the ground and 100,000 feet, but you can put things in trees and stuff like that.
Sounded like they were going to try some. Melissa, can you oh, that looks so cool. Can you unmute?
We're seeing you, but we're not hearing you. Out in the field, sometimes it's difficult that way.
Yeah. Oh, and then we lost her. Okay. All right. So let's go back to talk a little bit more about GAVRT, and then we'll see. Oh, wait. We're just going to play it by ear. And also, astronaut Dan Tanny is trying to join us. He's having poor service. We know that's going to happen across the path of totality. So we're just going to let everybody join in when they can. Let's go ahead and advance to the next slide and see what we have.
There's that balloon going way up high.
That balloon is looking awesome out there, Melissa. Yes. And Melissa, if you can hear us, one of our students at Norton Science and Language Academy, Stephanie, was asking about some aftermaths of the eclipse. And we were wondering if your student who is tasked to, or your team who's tasked to look at animal behavior, can talk to us a little bit about what happens after the eclipse and maybe how long it takes the animals to bounce back. I don't know if you heard any of that, but I'll text you just in case. Okay, all right.
We do have an exciting image.
Let's do it. Let's go to it.
Image.
It's actually not a radio image.
Oh, that's HIDAS right there.
There it is, courtesy of our High Desert Astronomical Society and Adrian Newland, a solar system ambassador. He just sent us an image from our observatory, and there it is right there.
Cool.
Way to go. Coming from California. We're getting some action.
And that looks pretty close to the maximum we're going to get, right?
Yes, about 11:14 or 17 is when we're about to get maximum.
Yeah, so we're only around 10 minutes away from maximum here in California.
So that's what we're seeing through our observatory just across town. Doesn't get much better of a view than that.
Yep.
All right.
Makes me want to run outside with my eclipse glasses
go ahead.
for a minute.
From the kitchen,
Yeah.
it's actually a great view.
Yeah, go ahead and go.
I'll be right
I'll hold
back.
down the fort.
Yeah, we can try.
Do we have any more questions?
Yes, how about a question for Marin?
Because we're gonna lose. Marin, are you gonna hop off here shortly?
I will, but I'll take this last question.
Okay, let's take one more.
Why did you want to become
And I think, Lisa, I might need you to repeat it for me because I can't quite hear Ryan.
Why did you want to become a scientist, Marin?
Oh, okay, I did hear that. I think Ryan asked, why did I want to become a scientist? Was that the question?
Yes.
All right, yeah. Oh, wow, what a cool question. I don't know. So I really liked astronomy when I was a kid. I watched astronomy programs on PBS a lot growing up. I had astronomy books. And then in high school, I didn't necessarily think that I was going to pursue astronomy as a career or even physics, but I did enjoy my physics classes. When I went to college, I went to the University of California, Berkeley as an undergrad. And I, for a while, thought I was going to be a business major. I didn't know what I wanted to do, but I remember that in high school, I really liked physics, so I took some physics classes. And then it turned out that astronomy is really big at Berkeley. They have a really excellent astronomy program. And I decided, why not take an intro to astronomy class? Seems like a really cool application of physics. I took some intro astronomy classes, decided to major in astronomy, astrophysics, and physics, and then decided when I left Berkeley that I was going to pursue a PhD in astrophysics. So I applied to go to grad school, and I went to the California Institute of Technology to get my PhD, which I received in 2019, so not too long ago. And then I decided, why not keep doing this thing? I love astronomy. It's really cool to get to research the things that I would be interested in as a hobby if I wasn't doing this professionally. So I now work at NASA Jet Propulsion Laboratory as a research scientist. I'm still a radio astronomer. I get to participate in projects just like GAVRT Solar Patrol, so observing the sun at radio wavelengths. I'm also the project scientist for a radio telescope called the Owens Valley Radio Observatory Long Wavelength Array, or OVRO-LWA, which also observes the sun, but at very low frequencies, megahertz frequencies instead of the gigahertz frequencies that we're using to look at the sun today with GAVRT. So yeah, still on this journey, and still really excited, as always, to be an astronomer and a scientist. Feel like a kid every day.
All right, do we want to talk about what we're seeing? Bailey, why don't you take my place? We're going to introduce one of our other NASA scientists here. Bailey, go ahead and have a seat right here. Go ahead, right here.
What is happening now is we are looking at the right.
There you go.
Oh,
Have a seat.
yeah, yeah. We are actually looking at the eclipse of the active region. You see that on that map, the left one, not the bright one, the left one. So the moon is just passing across that. So on top, we are looking at the power level coming from collected by the antenna. So you can see as the moon blocks the region, the power level is dropping. So that is what gives us the information about the structure in the sunspot. So that is the curve we are after. We call it the eclipse curve, not image.
Nice. And I see it's leveling out. So it's leveling out, I assume, because the spot has become now entirely covered by the moon? Is that about where that's happening?
Right? Almost, not quite, but it should strictly go to 0. So we will wait for some more time. Okay. Thank you.
All right. Nice. Sorry. All right, so I think we are in the process of trying to coordinate with Dan, was going to try to join us. In the meantime, while we're waiting, do we have more questions to talk about, or should we bring up the next slide? Where are we up to?
I definitely ask another question.
Okay, let's take a question then, since we've. That's
when
the most
viewing
fun
through
part.
eclipse glasses, are sunspots visible?
So when you're viewing through eclipse glasses, yes, maybe sunspots are visible. It depends on how big they are and how good your eyes are. If you have a telescope or something like that that can handle looking at the sun and magnify the image, you can definitely see sunspots from looking at the sun. And of course, with a telescope, all the more important to be aware of what's going on and either have a proper filter on the telescope to protect the telescope and you, or eclipse glasses, or both. That telescope makes it even brighter. But without any of that, with just the eclipse glasses, my eyes in general are not good enough. I have never managed to see a sunspot with just my eyes and eclipse glasses. but there are people who have. So probably depends on how big the sunspot is and how good your eyes are.
Okay.
What are we up to?
I think let's go back to what's the next slide? I think a lot of people right now are really enjoying the eclipse as much as we can. So let's go ahead and advance. Oh man. Let's talk about why this is such an exciting time. I think we have people out all over the place. We want you to keep enjoying. We can't wait to hear reactions as you continue to have that experience. So let's talk a little bit about this. Okay.
So we had the slide up that talk about heliophysics big year. I don't know if Marin is.
I think she's out viewing.
She's off viewing. Let's save that then and talk when she's back about it,
Okay.
because I won't do it justice. The short version is, oh, here she is.
There she is. What's it looking
I'm
like,
here.
Marin?
It's cloudy here, but it is getting darker. I don't know if you can tell from the lighting in the camera, but it's definitely darker in the environment. It almost feels like it should be more like dusk right now. We're hoping that the sun comes out through the clouds, but it's not looking too good. But I think it'll still be cool because we'll still experience that day to night transition during the less than 2 minutes of totality that we'll get in Austin. So I am going to hop off, but I'm happy to speak to this slide right before I do. So one of the reasons we're so excited for the eclipse this year is because it's part of a larger NASA program called the Heliophysics Big Year. So this name actually comes from the concept of the big year in birding, which if you're an avid birder, you'll know all about the big year, but it's essentially a year in which birders go out and try to look for and photograph as many different species of birds as possible. And NASA called this the Heliophysics Big Year because we want as many people as possible, both professional scientists and citizen scientists, so that means you watching right now, to participate in observing the sun, doing exactly what we're hearing about our students doing out in the field right now, observing the sun, taking data, and just learning about the star that is our closest neighbor. So the three big components of the Heliophysics Big Year are, one, the annular eclipse that we had last October that went through the lower 48 states. The second event is the one today, the total solar eclipse that's going through Mexico, US, and a little bit of Canada. And then closing out the Heliophysics Big Year is what we're calling the Parker Solar Probe's closest approach. That'll happen at the end of this year. Parker Solar Probe is a spacecraft that's orbiting the sun. And what's really exciting about its closest approach, as you might guess from that name, is that it will be the closest thing we've ever gotten to the surface of the sun. I think, Steve, you described it as it will kiss the surface of the sun in December of this year. And it will also be, Steve, you pointed out to me last week, it'll be the fastest moving thing that humankind has ever put out anywhere in space, in any place. So it'll be moving really, really fast as it approaches the surface of the sun. So that's what the big Heliophysics Big Year is. We hope that all of you listening now will join us as part of the Heliophysics Big Year and participate in GAVRT Solar Patrol. All right, I'm going to officially disappear for totality. I hope we see something cool. I'll report back when totality is over here in Austin.
All right, enjoy the moment.
Bye, everyone.
Okay, we just heard from HIDAS.
Thanks,
We did
Steve.
just get an image from HIDAS. We are in Apple Valley at our maximum that we're going to receive, which is 44%. So we'll be able to show images of that shortly. So if you are in Apple Valley, San Bernardino, or Southern California, this is as good as it's going to get right now. So hopefully you can feel that. You can hear our school bells are on a school campus. So exciting stuff.
Well, I have a battery in the car.
There we go. Oh, who do we have?
Check. Can anybody hear me?
Yes. Is that Dan?
Hello?
Hi, Dan.
Yeah, it's me. Hi.
Hey.
How are you?
Okay, welcome to Astronaut Dan Tanny. We don't have great cell phone coverage, but we can hear you. What are you seeing there in Pennsylvania?
Well, we're right on the border of Pennsylvania and Ohio, right at the shore of Lake Erie, a little town called Conneaut, I believe. And it's first of all really festive here. It's a beach scene. It's a beach on the shore of the lake, and there are, hundreds and hundreds of people here accumulating and getting ready. There's people playing volleyball and doing the stuff that you normally do out in a picnic, sort of whiling the time away. But we looked up and we can see the partial obscuration, so we know it's coming, and we could be right in the path of totality here. And we give a really mild cloud cover. Hopefully it'll pass out, or it'll get clear in the next hour.
Okay. Well, we would look forward to you giving us updates as you're there, and would love to. I believe, Dan, you're there with your son. Is that right?
I am. Yep, my 14-year-old son.
14-year-old. So we have a lot of high school students and a lot of TK through 12 students joining. So I'm sure they would love to hear a little bit of his experience as well. So as much as you can join, we'd love to be able to see what you're seeing, but we understand your cell service isn't great.
Yeah, it's I found it seems like the only place in the United States where we don't have Wi-Fi cellular service, but I have a work phone, and the work phone can make phone calls.
Okay. Well, we'll keep you on the phone, keep using that channel as much as you can. And then we'll have
all right.
Students, you guys can and participants, you can submit questions. Dan will continue to join throughout the broadcast, so we'll make sure that we get those questions answered, what he and his son are seeing there in Pennsylvania on the shore. What a great place to watch.
Yeah, I think
beautiful here.
Beautiful.
It also gives us an illustration of the fact that the eclipse happens over time and space.
Yeah.
Right? We just finished
that's right.
We're at local maximum here in California. We just passed the time when the eclipse was as good as it's going to get here in the LA area. And there in Pennsylvania, you guys are just sort of starting out, right?
Yep, it's just starting out. That's absolutely right. I'm looking at it right now, and it's obscuring the like the 4 o'clock, 5 o'clock portion of the sun. Probably, I don't know how to give a percentage here. It's probably a 30-degree or 45-degree wedge of the sun, of the moon. So it's pretty cool. Pretty cool to take a look at it.
Yeah, it is cool. That's why it's also so great that we have people all across the nation observing in so many different locations and joining in and telling us what you see and feel and are experiencing, because we're all getting it at a little different time.
Yeah, if you imagine what it must have been like for people before that was possible. So if you think thousands of years ago, when there was something like an eclipse, you still could learn a lot about astronomy and about how our universe is arranged that way. But we have the opportunity to learn a lot more just from things like being able to talk to somebody in real time and say, oh, hey, the eclipse doesn't look the same from California as it does from Pennsylvania at the same time. If you imagine before people really knew that the moon went around the earth and that the earth went around the sun and what all the motions were and what all the times were, it was a complicated thing to try and figure that out, when the best comparison you could do with someplace else is talk to somebody weeks later. You remember when something weird happened 3 weeks ago? What did you see? That's a very different set of observations than we have available to us today.
My son and I were talking about it, and we were wondering when were we humans able to predict solar eclipses? How early were we able to have models of the sun, earth, moon system to predict the first, the solar eclipses? Does anybody know? Did I miss that?
I don't know.
It seems like something that they.
Go ahead.
It seems like something in the couple hundred BC time frame, but that would have been pretty amazing. But I don't. We were wondering about it in the car.
I think it's got to be much more recent than that, because if you think about, the pattern, the duration of the pattern is so long that it's unlikely somebody just noticed what the patterns were without the understanding. And the understanding of what
doesn't seem periodic too.
Yeah, that's
right.
Kepler.
Yeah, it doesn't seem periodic to an individual observer. So yeah, I don't know. Well, you can imagine the 1600s, the Galileo, time frame. You would think they would have known that by then, because they were able to do really precise predictions of the motions in the sky by then. So
Right.
I don't know. I'd be interested. That's a little piece of research I'll do when I get back.
So Kepler and Tycho Brahe, I think, were the people who did the really great set of precise measurements.
Right. Yep.
So
Yeah, Brahe was amazing. He went to his backyard every night for decades and took maps of the sky every night. Unbelievable. So, okay, great. Well, something to figure out.
So for those just joining, we are having a conversation, although you cannot see him, with astronaut Dan Tanney there in Erie, Pennsylvania, viewing the eclipse with his son. And this is Dr. Steve Levin from the Jet Propulsion Laboratory. I'm Lisa Lamb from the Lewis Center for Educational Research. We're taking questions from all over the country and probably all over the globe, because we have GAVRT students all over the world. And so make sure to send in those questions that you have, as different parts of the U.S. are experiencing different levels of the eclipse in this exact moment. So,
and I'll just, again, since there are some people probably at any given time who haven't been here since the beginning of our little broadcast, I'll point out what the radio telescope is doing right now. So having made a radio image of the sun so we could see where the active regions are, think sunspots, but in the radio they're brighter. What's happening right now is tracking one of those bright spots, one of the sunspots, an active region on the sun, as the limb of the moon goes across it. The idea there is if you monitor this bright spot, when the moon blocks off part of it and then comes back and unblocks it, that motion lets you get more detail about what's going on, about the structure of that bright spot, than you would be able to do if you didn't have the moon cutting across it the way it does during an eclipse. So we're doing science trying to get more detailed measurements of the active region of the sun, or an active region of the sun, at 4 different radio frequencies using our radio telescope.
All right, so I've got a couple questions that, Dan, if you're still able to hang on the line, I'll ask to both you and Steve. So,
okay, sure.
Why is today so special? Why is everybody so excited about it? And then also, when is the next eclipse that we could experience? So maybe, Dan, you want to take that, and then Steve, you can add to it?
Sure. Well, there's perfect alignment today of the sun, the moon, and where people stand on the earth. So that's sort of cool and special, and it's a rare opportunity to see it, and I think it's kind of fun that we many of us have put our lives on hold to come out and watch the shadow of the moon come across the earth. So I think it's just kind of fun and interesting, and you know, it's an opportunity to appreciate how, I guess, complex and interesting our even just our 3-body system is: the moon, sun, and earth. And then when's the next time? I think it's in North America. I think it's 2044 is what I remember hearing. But some places, total solar eclipses happen fairly regularly, every couple of years. But you just got to be in the right place on the earth to see them. And so I don't know. I'm sure somebody's done the predictions, but I guess if you want to travel to, I don't know where, Australia or Antarctica or other places, you might be able to catch the next one.
Yeah.
Right. So I don't happen to know them off the top of my head either, but it is something you can look up. And the key here is, here in the United States, this is a very rare event, because in any given spot on the earth, you're not going to get an eclipse every couple of years. It'll be somewhere on the earth there's a eclipse every once in a while, but it's decades apart. And I will also say there's real science we can do during an eclipse. It's fun and it's exciting, and it's an opportunity to appreciate the wonders, but we can go deeper than that and appreciate those same wonders of the universe by measuring things during an eclipse that you wouldn't be able to measure otherwise. So as I mentioned, the radio telescope can measure some things during the eclipse that we would not be able to measure otherwise, just because of the sharp edge of the moon. There are also experiments going on to measure what happens to the Earth's ionosphere. If you think about how it works in the very upper reaches of the atmosphere at the edge of space, where only Dan can tell us what it's like personally.
Yeah, the only one of us who has experienced that.
The bright sunlight tears the atoms apart. It takes neutral atoms and breaks them up into ions and electrons. And if you turn off the sun for a little while, you're going to get changes. Some of those, you're no longer tearing the atoms apart for a while. Some of them recombine, and watching the pace at which that happens and which atoms it happens to in which way tells you a little bit more about the ionosphere than we would have known without the eclipse. Similarly, as we mentioned, some of our students, especially in Texas that we've been talking to, are doing observations not only of the surrounding weather and what happens to the local weather during an eclipse, but how the animals react. And that also is a way you can actually learn a little bit more about how animals behave and how important the sunlight is to them and so forth by learning about what they do when they have this unexpected brief moment of just a few minutes where the entire surrounding area is in dark, and some of the animals think it's nighttime and so forth. So there's actually real science we can do still with these eclipses, in addition to the sort of wonder and the beauty of it.
Okay. One more question I have for both of you. Why is safety so important? So we have our little safety slide up, but why, we're talking a lot about the eclipse and talking a lot about safety. Why is that so important during an eclipse?
Well, eclipses are hopefully the only time you look up and focus on the sun. so you know, you can get your sun in your eyes and it's really bright, but you don't really look up into the sun, I hope, on a regular day. But now, if you want to see the moon going across, you want to look straight at the sun. And so you don't want to, you know, you can certainly damage your eyeballs permanently. And so you don't want to do that. So the only thing special about an eclipse is that's in a moment, that's an opportunity to look at the sun. And so we wear special glasses to do that.
Yeah, and I'll mention, as I have a few times, but just to make sure nobody misses the message, it is always dangerous to look at the sun without some sort of protection. The only time when it's safe to look at the sun without those eclipse glasses is if you are in some place where you are going to experience totality during the moment when the moon is fully blocking the sun. You can take your glasses off and look for a moment and see the corona, but you don't want to be looking at the sun when there's even a small part of it that's still visible, because the sun is so bright that you will damage your eyes. And in fact, your eyes tend to adapt to the dark, even though it's getting darker and darker as the sun is partially blocked. Your eyes are allowing more light. It's still dangerous to try to look at the sun. Also, during a normal day, if you happen to look at the sun, your body has a good way of telling you this is a bad idea. It hurts. It's hard to look at the sun, and that's why we typically don't try. But if there's an eclipse going on, first of all, the sun might be partially blocked, so it's not quite as hard to look at the sun, even though it's dangerous. And you're really interested in the eclipse, so you might be tempted to force yourself to go through that pain and look at the sun. But remember, the pain is your body's way of telling you, don't do this.
Yeah. Okay.
Hey, I have one other comment to make, and that is one of the favorite things. One of the reasons solar eclipses are my favorite things is an unbelievable coincidence in our world, and it is unbelievable that the size of the moon is exactly the size of the sun from where we stand. So if you think about it, it makes there is no reason that when you look up at the moon and you can sort of cover your thumb with it or something, and then the sun, they are exactly the same size to you, okay, because the sun is much farther away. But that's a complete coincidence. And so the fact that we get this corona view of the sun because the moon perfectly overlays the sun is a complete coincidence. If the moon were bigger or closer to us, the whole Earth would get a solar eclipse. And if the moon were a little smaller or further away from us, you would never get a total solar eclipse. You know, a smaller moon would pass through the sun, and it would be a partial eclipse for everybody. So, unbelievable coincidence that to us the moon and the sun are the same size.
And just to add to that a little bit, because Marin pointed this out an hour or so ago, it's a coincidence in time as well as space. The Earth is 4 billion plus years old. The moon has been around a very long time. And if you looked, say, 1 million years ago or 1 million years from now, the orbit of the moon is changing, and those things
That's right.
would not align, and you would not get a perfect eclipse this way.
Yeah, you're right. We're very lucky.
We have a question that's a little bit similar to that from Jessica Rodriguez. We have a question for you, Dan. Are there any astronauts who have taken a picture of an eclipse from space?
That's a really good question. I don't know the answer. I suspect that they've tried. I've got to think that they exist because we've been on the space station for 24 years now. So I don't know. That's a good Google question to ask. I know a couple of friends that are astronauts that couldn't wait. Would love to do it. That are so interested in it that would love to do it. But and I haven't looked at the predictions of where the ISS is right now. If it's going over North America, but it would be a great opportunity to take the picture now.
It would be really cool to see some of those pictures come back and for us to see.
Yeah.
Compare them with our little observatory here in Apple Valley.
I imagine that
Right.
would be pretty tricky, right? Because if the ISS is, even if it's in the right spot, it's not going to be in the right spot for very long.
It goes so fast.
Yeah. Well, we're good at that. We're good at taking pictures of particular parts of the Earth. It does go by pretty fast, but same thing with hurricanes. We've seen pictures of hurricanes and other types of local phenomena, and it's possible to do.
Just curious, I have a question. Dan, what was your favorite picture or thing that you saw when you were on the ISS?
Let's see. A couple things come to mind. I got, at the end of my mission, I got some pictures of the pyramids in Giza outside of Cairo. That was pretty cool to see.
Yeah.
But I'm a golfer, and I couldn't golf while I was in space, and so I had a little project to take pictures of golf courses from space. And so it was fun to go find because they're fairly easy to see if you can zoom in a lot. And so it was fun to take pictures of some pretty famous golf courses and then send them the pictures from
I was
space.
gonna say, I'm sure those golf course managers really probably got a kick out of having their picture taken from space. That's pretty amazing. I'm sure those pictures are framed in every single one of those golf courses you captured.
That's pretty fun.
Yeah.
What's funny though is nowadays Google Earth creates almost the identical pictures. So, but whatever that was 20 years ago, it was not as easy to get pictures from space like that.
Yeah, that's really neat. So how are conditions looking out there on the beach?
Good still. Still a little cloud cover, a little intermittent cloud cover, but the sun pokes through every once in a while. So it's getting a little busier here, and I think people are getting excited.
Cool.
What do you think, John?
It's looking pretty good. There's clouds right above where I am right now, but it's clear over Lake Erie, and
I'm trying to figure out the way the wind is blowing the clouds.
I think we'll be able to get a view of the sun anyway.
Well,
The
we
clouds
really
are pretty
hope
thin.
so.
Yeah, you can. Yeah,
You can really see through the clouds, so it shouldn't be much of a problem.
That is terrific. We have our student Eclipse ambassadors here, John, who are high school students in California at one of our Lewis Center high schools, and they have a lot of sunny skies. I think they're going to be joining. There they are. You guys are on the phone only though, so I don't think that you can see them. But hey, guys, out.
Yeah, we can't.
Here outside in Apple Valley, we have astronaut Dan Tanney and his son John. They are on the shore in Erie, Pennsylvania. Can you guys? But they're only on the phone line. So can you describe what you guys are seeing here in California and what you've experienced in the eclipse so far, and maybe some of the readings you're taking?
Yeah, so we've been out here pretty much the entire time during the eclipse. So we've been using our glasses to look up, and the moon kind of came in at around, I'd say 10:30, at around 10:20. 10 o'clock to 10:20. We saw the moon peek in a little bit on the southeast corner, and then just slowly go across the middle, with it peaking just around in the center at 11:24. which just happened a little bit ago. So we saw that and it was really cool. But what we've been measuring and what we've been feeling definitely is the temperature decrease. It went from, we have a device here that is measuring the temperature, and it gave us a reading of about 77, which then we saw decrease as low as 58, 59, and around there. And with the little bit of a breeze that we're having, we could definitely feel that difference. And right about now, we are seeing a little bit of an increase from the last time we checked it at around 11. We've seen about a 7 to 8 degree increase now that the moon is regressing away from the sun. And yeah.
So we have 3 different
Cool.
valley. So my monitor now is reading about 74 degrees Fahrenheit, and then mine's
sure,
reading
show
about
off.
60.
I'm sorry. Go ahead.
It's a little colder than
Sean.
that.
Yeah, 74. Yeah.
And then mine's about 71 degrees Fahrenheit, and my humidity is currently at 22.
Yeah, I said my temperature, but my humidity is at around the same at 24. We saw a little bit of a humidity increase towards the peak. We got measurings around 30% humidity, and now it's going down a little bit. Yeah.
So do you know if
All right, I'm scratching my head. I'm trying to think how the eclipse will affect humidity, but especially with the decreasing temperature. But anyway, I'll have to think about that. That's really interesting. Good piece of data.
If they're measuring relative humidity, then cold air just doesn't hold as much water, so the same amount.
Right. Okay.
Your relative humidity.
There we go. Okay. Well, but then colder would be less humidity, I would think. Is that what you're observing? Less humidity or more humidity during the eclipse?
It'll be higher relative humidity.
Higher.
So that depends what you're measuring, right? Do you guys know if you're measuring relative or absolute humidity?
So we have, it is a relative spectrum, but we do have like maximum and minimum humidity on the same screen that we're looking at. And then we're also just, whenever we say it, we're giving out our current readings with the humidity and the temperature.
So there's a definition of relative humidity is the fraction of the humidity that's the area is capable of holding, right? And because colder air can't hold as much water, you could have the same amount of water in the air.
I see.
Air down, and it'll be
Got
a higher relative humidity. So I think that might be what's going on with your instruments, guys.
Yep, good one. Okay, great. It feels a little cooler here over the past half hour, and but we don't have a device with which to measure temperature.
Yeah.
So, but anecdotally, it's a little chillier.
Yeah.
Feels a little chillier. Yeah. What is the temperature about there in Pennsylvania?
What's the guess here? Probably 50, 55?
They're not wearing short sleeves over there.
50 degrees or so. I'm sorry?
I said, you guys aren't wearing short sleeves there. Our students are in their short sleeves. And the sun is
Well, we try. We're optimistic. So well, I'm in short sleeves, but I need to put the sweater on. Mm-hmm.
Very good. Very good. Okay. Melissa, I don't know if Melissa Poor hears us from the field, literally the field in Texas. Melissa, are you hearing us? She might just be enjoying totality in all of the measurements.
Where are we? 43.
Okay. Well, I'm gonna step out real quick. We're gonna take some. I'm going to turn over to Dr. Velu, who's going to explain some of the GAVRT observations we're receiving right now. Come on over, Velu.
Okay, we were going to sign off for a bit. We'll dial it back in about 20 minutes or so.
Okay.
Okay.
Thanks, Dan.
We'll talk to you soon.
Okay. All right. Talk to you later. Bye.
Bye.
From the observation deck. Okay. So we just completed the map, GAVRT map, which is on the right side. You can see a crescent moon. So this is just now made. What is on the left is what was made previously. Remember, there were 2 active regions on top. So one is gone. That is actually behind the moon right now. So our next observation will be as the moon leaves that, or as this region emerges from behind the moon, we will observe it again.
Right.
We will get another eclipse curve. Remember we showed before. So that is our next observation. We are getting ready for that. Anything else?
All right. Thanks, Phil. So paradoxically, we actually learn more about the active region that's covered by the moon than we do about the one that's not, that never gets covered. So as Velo mentioned earlier, when the moon is gradually covering up that active region, by measuring the brightness we see from the active region, we can get the eclipse curve. We see the brightness dropping as the moon gradually covers it up, and that tells us about fine structure in the active region that we would not otherwise be able to see.
So it is actually fortunate for us, because while it was covering, it was sort of scanning in one direction. So now when it's coming out, it is coming out in a slightly different direction. So basically you are scanning a region with a very narrow beam, you can say, in 2 directions. That means we get a lot more information about that.
And that happens because of the placement where the active region happened to be, right? So that
right, and also the moon's path.
Right.
It's basically how the moon's path across the region.
So that worked out to be a pretty good observation scenario for us.
Okay.
Right now, are we back to staring at that same active
right
region?
We are going back to the region, so that as it comes out from behind the moon, we'll get more information on that. Okay, let me get started on that.
Okay.
Thank you.
Thank you, Val. All right, so let's see what we have going on and who's available to talk with us. So let's start with our folks online. I don't know if Marin or any of the folks in Texas are available at the moment, or they might still be. It's pretty close to totality there, so they might be offline.
Yeah, if they're offline, we could hop back to the NASA stream.
Yep. Want to take a look at the NASA stream for a minute? I guess we might as well put the sound on there too, if you can.
Here in Florida are experiencing that partial eclipse. As always, if you are in a partial eclipse, be sure to be wearing those eclipse glasses to protect your eyesight as you're viewing it. But you can see these bands here are greater than 75% view. So say you're watching up in, I don't know, Milwaukee here, for example. You've got a great view, almost 100% coverage. You're not quite at totality. 89.4%. Looks like you got good cloud cover there. 20% cloud cover. So hopefully you got a nice view up there as well too. I've also put on this overlay here to show you just the amount of the duration of totality. You see, a lot of our places are within this middle band right here that are getting more than 4 minutes. It may seem like a lot of time, but as you've seen, just how quickly that can go by. Michael, it sounds like you wrote his whole dissertation, a 5-year piece on those just few moments there. This just passes so quickly, and again, if you miss this, the next time you're going to have to wait for this in the U.S. is not going to be until 2045. So again, make sure you're previewing exactly when to expect that peak time of coverage wherever you are in our path of totality or even outside of that path of totality. So a lot coming up very soon. Again, our friends in Russellville look like they have great coverage there as well too. Only 9% cloud cover, so hopefully they're getting a really nice view. But let's check in with Jasmine up there to see. Hopefully you're looking good for there. How's it looking up in your way up in Russellville?
Everything is looking absolutely fabulous here in Russellville.
12 seconds, they'll be in totality there. So just keep on this for a minute or two.
In the downtown depot area. Joining us now is heliophysics expert Dr. Patrick King, all the way from BC. How are you feeling about your very first total solar eclipse?
I'm incredibly excited. As I'm watching all the changes that are going to grab, as I'm watching all the changes, I'm thinking back to the textbooks that I've read, and so it was all academic before. It's no longer academic.
Yeah, so the feeling is very different than what we might read in a textbook. Patrick, just explain, describe the atmosphere around it as it's changing.
Right now, as I'm looking around, of course, the temperature has been falling for the last 20 or 30 minutes, but the light is dimming and it's dimming faster and faster and faster. It seems like it's accelerating. The crowd is definitely getting excited. I'm looking around the ground to see if I see the shadow snakes. I don't, but this is just really exciting.
It really is. Honestly, like you said, we're feeling that cooler weather. Yeah. The crowd behind us just erupted. We're also feeling them fall a little bit quieter too. Right. So we're going to take a beat of silence as we get into totality. I think we're less than about 15 seconds away. So we're going to also look over our shoulder with our solar flashlight still on until we are in totality. Here we go. Just a sliver of the sun left.
Crowd getting excited.
The crowd, yeah, all around is completely electric.
Going.
Oh my gosh.
Going. Wow.
Oh my goodness. Here we are.
Here we go. When Parker Solar
For
Pro
this.
passes
Oh, they're not hearing this?
Oh, I'm mute. Oh, yeah. I'm mute.
Oh, wow. I'm sure that means a lot to you because you worked on Parker Solar Pro about 20 years ago during its inception. So tell us a little bit more about that.
I worked on a concept study for Parker Solar Pro back when I was a graduate student in around 2002 or so. And back then, the idea was for it to actually dive into the sun rather than orbit the sun. So it was going to be a sun dive.
Wow, that is fabulous. This must be a very full circle moment for you, right, Patrick?
Brilliant. This is absolutely brilliant. And that diamond ring has been persistent. Wait a minute. That's pink. What we are actually seeing is down into the chromosphere now of the sun. We're seeing a little bit deeper than the corona. I believe. It's because of the pinkish color. We're looking down into the chromosphere, which is the next layer of the atmosphere of the sun down.
Oh, wow.
Wow.
This is like nothing we have ever seen here in Arkansas, and like nothing we will see for the next 2 decades, right, Patrick?
That's right. It's going to be 21 years before we see it again here. 2045.
All right, so as we are starting to exit totality, of course, we're going to be very careful with our eyes if needed. We're going to put those solar glasses back on, of course. And the crowd just erupting fallen quiet again as they walk with that
Wow.
signal.
I'm actually seeing bats splitting through the air.
Oh, wow. Well, we will be very careful then.
Yeah.
And why is that, Patrick? Again, those nocturnal animals are coming out, right?
As far as they're concerned, it's nighttime. It's time to feed. So they're coming out to feed, and all the mosquitoes are in the swatter.
Okay, got it. We'll be very careful for all those nocturnal critters around us right now.
All right. We are getting closer. Get ready to put the glasses
All right.
on.
We're putting those glasses back on. All right. Second diamond ring, seeing from right here in Arkansas, the Diamond State. Absolutely stunning.
Outstanding.
Beautiful. Patrick, we're going to turn around now and just one question I really do have.
Okay.
Before we let you go.
I think that we should. All right, so we're going to move away from the NASA broadcast there in Alabama. That was exciting. I don't know about you guys, but I got chills all up and down my arms. And so now let's go to Dr. Marin Anderson, one of our GAVRT scientists and NASA JPL scientists, and see what that experience was like for you all there in Texas near Waco. Marin, do we have you back? Oh, did we lose her? Okay, just kidding. All right. Okay, so like we talked about before, it's a time and space phenomenon, and everybody across the country is experiencing this in different times. But let's go. Steve, where do we want to go next while we're waiting for Marin to join us back?
Well, we can always take questions if there are some, or we go to the next slide and see what we have as reminders for things we wanted to talk about. I will mention just in passing here, because we were talking about how the eclipse is different in lots of places, and people were asking about that. I will point out that the spacecraft I work on, Juno, is out at Jupiter, and it's also experiencing an eclipse in a few hours today. Completely different kind of eclipse. It's going behind Jupiter, and its solar panels will be out of the sunlight for several minutes. Just kind of an interesting coincidence for us. The way you want to treat an eclipse on the spacecraft is very different than what you care about here on the ground.
Yeah.
But things are just piling together all at similar times.
Mm-hmm. I want to take just a moment really quick, Steve, to give a special shout out to somebody who's online. My sixth grade teacher, Miss Julie Bear, is online. She's joining from Arizona. So I just want to give her a shout out and tell her thank you for being so amazing, and to all of the teachers who are joining us to learn straight from all of our scientists across the country, and learn something like, who knows what it's like for spacecraft at Jupiter other than Dr. Levin. So thank you to all the teachers who are allowing your students to engage with us, and for all of those teachers who may be retired now, but still, poured into those of us who are here.
So while I could talk about this slide, I'd much rather let Marin do it.
Okay.
If she's available and online, see if we can join her in. I want to hear how it went in Texas.
Before that, while we get Marin settled and she is getting all rejoined, let's go ahead and talk about how we can learn more about getting involved in GAVRT as a general. I think we have a good slide there. All right.
Yep. So you want to kick that off, or you want me to talk about it?
Yeah, go ahead and talk about that, and then we'll know Marin's ready when her camera's back on.
Okay, so there's a picture of our radio telescope and a link to go to the GAVRT website so you can read about how to join in with us. Remember, what we do with GAVRT is we take this big radio telescope that you're seeing there, 34 meters on a side, 12 stories tall, and we use it to do real science. But it's not professional scientists doing real science. It's professional scientists and citizen scientists, K through gray, we like to say.
Yeah.
Anywhere from kindergartners all the way up to senior citizens who want to work with us, teachers especially, of course. We have educational programs. We like to tell ourselves that we're trying to do real science and real education. Mm-hmm. So a key part of what we do with GAVRT is that the use of that radio telescope is for things that are valid scientifically, where it's scientific research that needs to be done. We're not just duplicating something that somebody else has done. We're trying to do observations that are valuable scientifically and will contribute to the world's body of knowledge. And we are also trying to work with students and teachers in a way that the education is also something that needs to be done. And I guess I should turn that over to you, Lisa,
Yeah.
to talk about the education part.
Yeah, the education part. So my background, I am a classroom teacher, middle school, language arts and social studies. So I don't come from a science background, but I was fortunate to work in a school that exposed me to a program like this, like the GAVRT Radio Astronomy Project. And I got involved really early on into my tenure here at the Lewis Center. And so the one thing I want to share with all of our teachers out there is you don't need to be an astronomer or an astrophysicist or have any very specific background prior to getting involved in GAVRT. All we need is for you to have a love, a curiosity for learning, and to be open to doing something that isn't so scripted, right? So a lot of times our textbooks, we know that there's an exact answer, there's a scope and sequence to turn the page. We're actually able to engage in real science with NASA. We're collecting data real time, we're analyzing it. And that comes along with all of the parts of the scientific process, learning how to think like a scientist. I know that for our students who have been engaged with GAVRT all around the world, that's probably the biggest takeaway. Whether you want to go and work for NASA or pursue a STEM career or not, the skills that you learn in GAVRT really apply across the board. So that's what we're excited about. And we're here to guide you every step of the way. Nancy is our lead operator, along with Erica. They actually will take the reins for the most part and guide your class through a GAVRT session. And then as you get more comfortable, you can kind of assume more of the reins. And so we're happy to take as much of that or as little of that as you want us to, and that you feel comfortable with. And we're happy to join you and explore.
And I'll also point out that something we often see is because GAVRT is so different from reading things in a book and getting the results of science that somebody else has done, students are not only learning about the process for doing science and learning about science as opposed to the results of science, but it also sometimes appeals to a different kind of student, or the student who does really well at GAVRT might not necessarily be the same as the student who does really well in some other part of the educational experience. And we think that's really valuable too, to recognize that human beings are unique and they're not all the same. And some of the ways that you can interact and learn using the radio telescope are enough different that if you're a teacher, you might be surprised at which are the students who turn out to be stars in GAVRT and which are the students for whom it's just another activity.
Yep, that's definitely true. So we hope to partner with you, getting word in from some of our folks who are in the path of totality. Melissa and her big crew, cell service is really spotty in some of these areas. And so some of our partners are having trouble joining back in, but we are fortunate to have Marin. How was it?
Hi, can you guys hear me?
Yes.
All right, it was great. So we managed to just catch a little bit of totality through the cloud cover. It didn't look good going into totality. It was getting really dark, so that was exciting. The library lights outdoors came on. It got really quiet, and we didn't think we were going to see anything because there was so much cloud cover. But during totality, maybe 30 seconds in, for about 10 seconds, we saw the corona. We saw what I think was a solar prominence towards the south and the east, which I think is near one of the limb targets that we have in our GAVRT observations. I think Nancy and Belu were targeting that source, maybe either during ingress or they will be targeting it during egress. So we actually saw that active region and the solar prominence associated with it with our eyes. Lasted for about 10 seconds before more clouds came through and obstructed our view. But it was really exciting. It was really dark. Everyone started cheering when they saw the corona during totality. And then it was over. And it started getting light again. It kind of felt like dawn. The birds came out and started chirping like they were getting ready for sunrise. And we haven't seen the sun since. So we just managed to get the perfect view of totality for about 10 seconds there. It was very exciting.
A life-changing 10 seconds, I imagine.
Yes, it was very cool. And now we're already planning our next trip to Iceland in 2026.
That's what I was going to say. Everybody who experiences a totality, I feel like you then become an eclipse chaser. You once that difference that you guys were talking about earlier is from 99% to 100% is everything. And you just want to experience that another time. That's so cool. I'm so glad that the clouds cooperated.
Yes, it was a magical moment.
Oh, amazing, amazing. Yay. And so Melissa and her students are still trying to rejoin us. Marin, we did have astronaut Dan Tanny join from Pennsylvania. He and his son John are going to be checking back in shortly. I know that I've been receiving messages from GAVRT teachers all over, Lee Coltman in New York and all over the place, tuning in to what we're experiencing. But maybe we want to take a few minutes to.
Well, I'm wondering if Marin wants to talk about
Yeah.
the slide with the corona and the view from space and the ground.
Yeah.
Yeah, sure. That sounds great. Yeah, so this is a really cool combined image of the sun. This is from 3 different sources. So in the center there, what you're seeing is a view of the surface of the sun as taken from space. That middle view, which almost kind of looks like a black and white image, that's the view that you get of the corona, the outer atmosphere of the sun, from a telescope on the ground during totality in a total solar eclipse. So that region only accessible during totality. And then the outer portions of this image are a view of the very outer layers of the corona, very high into the Earth, into the solar atmosphere that you get from space. And the way that we can study the corona regularly, not just during a total solar eclipse, is via space telescopes that have something called a coronagraph. And that's basically an instrument that covers up the bright disk of the sun so that scientists and solar physicists can study the corona, the outer atmosphere of the sun. And you can see from this image that a coronagraph is covering up a huge portion of not just the solar disk, but also the inner layers of the corona. So what's accessible from space is only the very outer parts of the corona. It's really special during a total solar eclipse because that means from the ground we can finally take observations of what's going on in the inner parts of the corona as it connects down into the chromosphere and then the surface of the sun. And there's a lot of science to be done here. A lot of solar physicists take observations during an eclipse in the path of totality so that they can study the structure of the magnetic fields and the plasma in the corona in those inner layers that you can only access during totality. And if you look closely at this image, if you look at the segment of the corona that we're showing here labeled ground, so the parts of the corona that you can access during totality, you can see what look like lines either coming out of the north and south poles of the sun there, or maybe even loops that connect down out through the corona and back into the surface. And those lines actually are magnetic field lines from the sun. And the reason we're able to see them is because really hot plasma, again, those charged particles that make up that hot soup of the outer corona, they're trapped along those magnetic field lines and they're producing emission. And so we can see via the emission produced by those particles exactly what the magnetic field of the sun is doing in the corona via those lines. Sounds like we have some guests that are tuning in. Is that right?
Yeah. Who are we hearing? Is that Melissa?
This is Dan.
Oh, hi, Dan. How's
How
it
are
going
you?
there?
Well, we're approaching totality here. I would say, looking at the sun through my glasses, it's a very narrow crescent right now. So there's probably 90% of the radius, or maybe 95% of the radius covered. And what's amazing is it just looks like an overcast day here. So the question of, is it really worth going for totality? You know, the answer is yes, because you would call this virtually covered, but it's still, the sun is so bright, it still provides, you know, an overcast day here. But we're minutes from totality. We're looking forward to it.
Well, if you're willing to leave your line open, we would love to hear the reaction there on the beach in Erie, Pennsylvania. Sure. Because I'm
right.
sure, like Marin said, it's going to be a big one. We saw Alabama from the NASA live stream. Oh, and then
Oh,
Melissa.
great.
I think we saw.
Oh, Arkansas, not Alabama, Arkansas.
Uh-oh.
So Melissa Port is also joining us.
Can you see?
Students? Melissa, Dan he is minutes from totality there in Pennsylvania. So we're going to have him, we're going to be able to listen into that. So,
Great.
yeah, we're excited.
Can you hear us?
We can hear you.
All right, we just experienced totality and it was incredible. We have a student that can tell about it.
Okay.
Oh, great.
Yeah, so hi, I'm Rita Agarwal, and I just experienced the totality, and I think it was so cool. And I think something really interesting was the noises we heard. So we have two recorders, one that's like on a lower elevation and one that's higher. And one thing that I noticed was the dog noises that we heard. And they were just howling so loud, and I'm so excited to like check the recorders and see what other noises we can hear. We also noticed that like the pond was like a lot more quiet. So before we heard like tadpoles and frogs jumping, and then we didn't in the middle of the eclipse. We also didn't hear birds in the middle of the eclipse, but we did hear crickets. So yeah, those are some of the things that we heard. We also saw flies. A lot of flies came out during the eclipse.
Yeah, and there were also like a lot of chickens like were going crazy, and then I remember some dogs started howling, but then like when it came back on, they just started barking again, and then people were like crying and screaming. It was like really cool. So
So we actually had a question for you guys about.
Oh, wait. Is that Dan?
Go ahead, Dan.
No.
No, it's not. So we had a question for you guys in Texas about that. Somebody had asked us about the aftermath of the eclipse, about how long it would take to recover. And we were wondering about the animals. How long do they take before they sort of settle down and you're not seeing things due to the eclipse in the animal behavior?
aftermath, like how long?
How long till they changed
know
back?
that.
Yeah.
Yeah. So my name is Nick Mendez. Something just to answer that question about the aftermath, especially with the noises. Usually it took a while, and I think that was really interesting. It's just that right after the sun like started reappearing again, it wasn't immediately back. It took I'd say like probably like a good 5 minutes before we started hearing like the birds chirping, like my peer here just said. But then also you kind of notice that there was still some stuff that kept going on, and you became more aware of the noises, especially after that silence. And then now we could still hear it, and it's just really interesting.
Thank you.
Okay. Let's listen in to how it's going in Pennsylvania. Dan, are you still on the line?
Yep, we're right here. It's just a sliver of sun, so seems like a couple minutes. And sure, I'll just leave the mic open.
Okay, sounds good.
It's pretty cool.
Yeah, very good.
People are starting to shiver.
Oh yeah, I remember from being in totality, it got really cold, very quickly. And then when the sliver of the sun came back, like on the other side, you could feel the warmth so distinctly. That was my experience. It's amazing. A little bit of sun.
Right now in the sky, there's a jet flying over, which is going to have an incredible view. I think of the of the eclipse. The jet is almost in line with the sun and the moon, of course, and so I'll bet they've got a great view of a disk of a shadow, a circle of shadow.
Mm-hmm.
It's getting noticeably darker right now. Yep. I would say, and
it's visibly less saturated.
Colors.
Less saturated colors.
Yep.
Interesting.
Yeah, there's just a tiny sliver of sun left.
It's going to be a big reaction.
You can sort of see that the sliver of sun on both ends is shrinking. It's
oh yeah, the crescent.
It's happening more rapidly right now.
Right.
You can see each end sort of fading away.
Some kids are counting down, I think, to totality down at the beach.
Yeah, right. And we did that too. We counted down. I wish that was in totality. My family and I got to do it last time.
So noticeably darker around. Yeah. Really kind of cool. Yeah, just a tiny sliver.
Mm-hmm. Yeah, it looks like an orange hair.
Yeah, yeah.
Hair.
Interesting.
Just think about how many millions of people are right now ready to go into totality.
Yeah.
There's so much population there.
Okay, so now, right. So now the horizon is like a red, like a
sort of pinkish.
Right, and then you can see the shadow coming from, what is that, the south towards us. It's really quite amazing. It's really cool. And so around us, let's see. Oh yeah, now it's
really happening right now.
Yeah, right. Yeah. Yep. Totality. Great. Oh yeah, you got the ring of fire. Yeah, so we've got the corona. It's really awesome, really beautiful. And my phone is not able to take pictures, but beautiful sunset reds off on the horizon. It is quite something. Beautiful. Can you get a picture, John?
Yeah.
Of the corona?
Sort of.
Okay. It's behind a cloud, but I mean it's really
incredibly like vivid.
Yeah.
Yeah.
Oh look, we can see stars there. That might be I don't know if it's Jupiter maybe. That might be a planet because it's pretty bright.
Yeah.
So, and it is it's 10 o'clock dark out here. Really quite beautiful. Somebody says they're setting off fireworks. Somebody's setting off fireworks.
Are they?
Yeah, to me it's sort of indiscernible from a sunset.
Yeah, right. Yeah, but the sun's nowhere near the
not
horizon.
at all.
Yeah. Okay, so I'm gonna get my sky app. I want to see what that is.
I think Venus and Jupiter are both nearby.
Say again?
I think both Venus and Jupiter are relatively near the sun. Should be visible.
Okay, let's see. I'm looking, right, and I guess Saturn's up there too, but it's cloudy, so we can't see Saturn. Looking, Mercury's up there, but really Venus is the only thing we can see here through the clouds. Yeah, this is just really something else. Beautiful. Okay, hold on. I'm trying to take a panorama picture here. Wow. Okay, so what's that at the 6 o'clock position, John?
Yeah,
It
what
looks
is
like
that?
there's a red dot.
I
at the
see
6
I see
o'clock
what you're looking at.
position.
Yeah.
It must be that let's see, it was moving this way, so that's the beginning of the
Maybe that's like just a flare from the sun.
maybe, yeah. We see a red dot at the 6 o'clock position as we're looking at the corona.
Yeah, really tiny red spark.
Huh. Interesting.
Yeah. Was it Alabama? No. Arkansas. Why do I keep doing that?
It's really beautiful to look out at the horizon here. We're on a little hill over the beach, so we can see continuous horizon over Lake Erie, and just this beautiful red. It was a little darker. It's getting lighter now because I think the shadow is moving away. So.
That is it, my friend. Dan, we have a question coming in for you.
Sure. Yep.
Can you see the comet that may be visible during the eclipse?
Oh, hold on.
Oh, no.
Hold on. We just got the engagement ring, where the sun
Yeah.
is poked out from the moon. Yes, I'm sorry. Go ahead. So now you can see shadows. Now shadows are being cast.
Yeah, watch the valley of the
Oh yeah, right. Yeah.
This is the most amazing thing ever.
Okay, you know what our job is now? Get in the car and beat the traffic. Okay, we're gonna move to the car.
Go.
So,
Were
yeah.
you able to see a comet that was supposedly maybe going to be visible?
I did not see a comet.
No. Okay.
Was that the question?
Yes, that was the question.
Now there's this eerie. So it's it's been a minute. Now there's a relatively eerie kind of light. It casts a distinct shadow, but it sort of looks like golden hour, that sort of reddish.
Right.
So it's kind of weird that it casts a 2 o'clock shadow or 3 o'clock shadow. So
with the telescope, I could distinctly see.
yeah, cool. Okay, so well, that was fun.
Thank you so much for sharing that with us, Dan and John. That's so cool.
Yeah, we really appreciate it.
Sorry we couldn't. Sorry the Wi-Fi the internet system wasn't good enough, but yeah, working. But
no.
Okay, so
you guys gonna run to the car?
yeah, we're so the concern is traffic, right? Let's try to beat the traffic.
Go.
But all right, well, great. Thank you for joining us here. It was quite something, really.
Thank you so
really,
much
yeah,
for
really spectacular.
sharing. Okay, we'll talk soon. Thank
Sure
you.
thing.
Thank you to astronaut
Okay,
Dan Tanny and his son John.
Bye.
Bye. Okay. All right. That was exciting. It's fun to see how the experiences are different in different places. Melissa, if you're able to come back on, and Dr. Marin Anderson, if you're able to come back on, Bob Twiggs, we'd love to debrief with you guys there in Texas and see what your experience was.
I see Melissa.
See Melissa?
Hi there. Can you hear me?
Yep.
Yes.
We're good.
We had all our students around that reported to you about the eclipse, and they were listening to astronaut Dan Tanny talk about his experience, and they were reliving it. And we were talking through some of the details that we experienced, and hearing each other's perspectives helps us realize everything we felt.
Yeah, that's so cool. Did any of your other students want to share experiences or feelings or what they're measuring?
Well, they do. They are still monitoring hardware and bringing it down. And here, I have one right here. Nick. So yeah, I have another student. We have Nick again here. And yeah, I was just sharing about listening to Dan experience it right after we did, what that was like. But out of this whole thing, everyone took all this time to come here, and I think it was worth it because I've been thinking about this so long. But what do you think, all these middle schoolers and people around us, and what do you think about this event we did?
Yeah, I mean, I kind of think about it like seeing these middle schoolers, I think focusing on the middle schoolers. I remember when the 2017 eclipse happened, that was when I was in 5th grade. And that's ultimately what sparked my interest in pursuing STEM and taking it very seriously in my career and my education. So I really feel for them, seeing this, experiencing this in totality is really going to solidify like, wow, this is cool. I want to learn more about this. And once they learn more, they're going to learn all about the amazing things they're able to achieve with it, they're able to put in. And I think overall with just everyone, this was just a big moment of just like coming together, showing that community, and really showing that we're all just here just trying to enjoy the amazing things that happen in our universe.
Well said.
Yes, for sure.
We have other students that will come up and join and talk. So how about I'll go locate them and I'll bring them on.
Okay. Sounds perfect. Sounds perfect. Messiah, do you guys want to get ready to go back out on location and share your takeaways and final readings? Okay. So let's see. What about Marin? Dr. Marin Anderson, are you in a place where you can? There you go.
Hi. Can you guys see me and also
Yes.
hear me?
Yeah, we can see you.
Okay, great. Yeah, it was really great hearing retired astronaut Dan Tawney talk about his experience while it was happening. That was really special because we went through a similar, but maybe not as exciting experience here in Austin because it was so cloudy. And one thing that this discussion made me think of is, you know, how fast the sun's shadow, or sorry, the moon's shadow is traveling across the U.S. When it entered via Mexico and then through Texas, the shadow was moving as fast as almost 1,600 miles per hour. And as it's going through the U.S. and exiting through Canada, it's speeding up to almost 3,000 miles per hour. So it's that umbral shadow, that path of totality is racing really quickly across the U.S., which is why it happened so quickly here and then so soon after where astronaut Tawney was located in, is it Pennsylvania where they were?
Yeah, they were in Pennsylvania. Yeah.
So yeah, it's a precious thing.
Yep, it's really fast. It's exciting to see how much data all of our partners have taken too. I'm excited for the follow-up work, especially that the Melissa Poor's students in Virginia, all the students she's working with in Texas, and our students here in California, and any other GAVRT students who want to join. I'm excited to see what our post-eclipse work will be as well, because I know that there will be quite a bit of it.
Yeah, I'm looking forward to seeing the follow-up on the radio data too.
Yep. So we're going to get a good spot here in a minute to talk about what our console is observing, but we have another couple minutes.
Do you want to hear from 2 more students?
Yes.
Sure.
All right, come on up.
Hello, I'm Alexander Beckman. Yeah, so the eclipse has happened here, the totality's happened, and we have all of our data, and hopefully we're going to get all of it back in just a few days. And I really just can't wait to see the citizen science from all across the country and all these different experiments all come together and just see what we find out and see what the trends are. And it's going to be really fascinating. So I'm so glad I could join this experience.
Perfect.
Hi, I'm Ella Brochu, and I think my favorite part about, seeing the eclipse and being able to experience it and working with the kids, experiments and being able to, hopefully find that data and kind of compare and learn a lot of things is being able to take this amazing experience that I've had and take it home and hopefully share it with my community and my school and kind of make a difference in my own community.
Been a great time.
So where did you fly in from?
I flew in from Alabama.
And where are you from?
I'm from Indianapolis, Indiana.
All right. And they also are repacking the hardware for your students so it can come back, and they're writing some notes, some field notes, and we will have those reports back to you. And we're looking forward to doing a partner meeting and reconvening and sharing the experience between the students.
Melissa, do you want to maybe we can let the students join together, because we have Natalie, Caprice, and Messiah on, so maybe we really haven't talked amongst each other post eclipse. So
he has Caprice's box.
Yeah.
Oh,
right over there.
It's right over there. So
see it, but right down there, that's Caprice's box.
And the rest of us are
The rest are spread out everywhere.
they're all across.
And where did you come in from again?
I came from Alabama.
Indianapolis.
So cool.
Did you hear?
Did you guys get a little bit get some of the gifts that the kids sent you?
Oh yes.
Thank you so much for the patches. And the notes were so nice. We love them so much. They made our day.
Yeah, I'll be bringing them home, and putting them on my shelf. Definitely,
Yeah.
they're super cool stuff. But
we try to
super
send in
fun.
things that were very, very small. But most importantly, did you get the duck from Bob Twigs?
We got the ducks.
Yes.
We got the little ducks.
Yeah, we got little ducks.
They're super cute.
The ducks are so, like, Caprice has her duck.
Look at my earrings.
Yes.
Caprice has her duck. We can't see your video, unfortunately,
Press like that. Put it on the top, maybe.
but it's in it before.
Oh.
Can you
So
see?
we're just having some videos. There we go.
But as soon as I saw the ducks, I laughed.
Yeah.
So
Oh,
those
we
are
have
from
another
Professor Twiggs.
student here. Say who you are and where you're from.
Oh, I'm Fernandez and I'm from Brownsville, Texas.
We're talking about the ducks.
All right.
All right, so we'll go off for a bit.
All right.
Okay,
Thank you.
thank you. Lewis Center students, you want to tell us a little bit about some of your takeaways?
So right now our readings are saying about 71 degrees Fahrenheit, and it just switched. I think it was about a 22% humidity. So it's definitely gone up. And then the difference of our boxes has been really interesting between the temperature. Yeah, mine's a little bit more of a cube. There's a little bit more of a rectangle. So that's made a big difference on our readings. And yeah, we learned a lot, and we can't wait to grasp the results. Currently, my temperature is reading 76 and my humidity is at 18%. So my temperature went higher than it initially was before we started, or when we first turned it on. It was originally at 69 degrees, and then my humidity it plummeted. It went about like 20 below how it started.
Yeah, the eclipse is completely gone, so my readings are pretty much back to normal. But we're getting a lot of different readings. There's a lot of variation between our three devices, which is very interesting. Because I'm getting right around 83 degrees Fahrenheit, and then 22% humidity. But yeah, it's really something. We'll see. We'll see pretty soon the actual relative changes that we had, and we'll be able to compare them with each other, and it'll be really cool.
Where were the devices? Where were your sensors set up? Were they all right near each other, or were they in different places a little bit?
Yeah, they were. We had two in my box, just placed right down in the sun, and then we had Natalie's box just a little bit off to the side, like 1 foot off to the side, just in her box.
Yeah, interesting that
Yeah, I
there's so
wonder-
much variance.
Right. I wonder why. Maybe it's something to do with the box itself gets a little warmer, absorbs sunlight better, or something like that.
Yeah. Mine has a bit of a different lid compared to
Yeah, I think my solar Eclipse Prime is like blocking out some of the sun or something.
Okay.
It'll be interesting for you guys to make some hypotheses about that and why it was a variance. And I'll be interested once we get all of your monitors back from Texas and to see what those readings were as well. It's going to be really cool to analyze that data. It looks like we have students from all across the country who were using those monitors designed by Professor Bob Twiggs. So that's super cool.
Yeah.
Yeah, and to compare, check out the radio data. Melissa, you have some more field correspondence?
I do. Say your name.
Hi, this is Kendall Huneber again. I'm a senior at Allen Academy. We just got some art data back, and we found that humidity spiked close to 20% towards the end of the eclipse, and it's currently going back to normal at about like the mid 40s. And then since this morning, the temperature has dropped close to 15 degrees Fahrenheit, and there was a significant like 7-degree change during the eclipse, and it's also slowly returning back to the levels that it was before.
Did you predict that ahead of time, or you?
Yes, ma'am. Those were our general predictions, and then we also measured barometric pressure, but that didn't change at all during the eclipse, so that's like there's no significant
Were you
correlation between
surprised?
that and the eclipse. I was actually by the significance of the changes. I thought that they were going to be much more minor, just because the totality was only for about 4 minutes. But the changes were very significant. That's going to be really interesting when we try to graph that data and analyze that later.
Excellent. Yes. Thank you.
Thank you.
All right. I'll find another student for a report.
Okay.
Thanks.
Marin, did you want to share? We're still waiting for some GAVRT data. We're gathering some GAVRT data, so we want to definitely report about that. But in the meantime, you want to share a little bit?
Yeah, I'm really excited to see what the GAVRT data look like. I know we were targeting a couple active regions, a couple limb sources. So really excited to reduce that data and see what the magnetic field structure looks like in those active regions. Things are wrapping up here in Texas. I was at the NASA, or I am at the NASA Sunspot at the Austin Central Library. Once totality ended, people started trickling away. There's only a few people left. Everyone's sort of dispersed, especially since it's so cloudy here, you can't see the sun anymore. I think the eclipse, the partial eclipse, has ended as well now. So yeah, we're just hanging out. I'm so excited to hear what's going on with the GAVRT data.
Okay.
We're just wrapping up with our GAVRT data. You want to show the. So you can still have our raster up from earlier, but this out of the sun's path, and we are free and looking at the sun. Dr. Bailey says that you got some fantastic data today, especially on ingress. A successful operation.
All right.
All right. I think that we could probably wrap up. I just want to give a very, unless Bob Twiggs wanted to come on and say, Bob, are you anywhere near yours? He's not on. Okay. Well, I just want to get. Oh wait, Melissa. Did you have anybody else who wanted to talk?
No, we just wanted to say this was amazing. It was epic, life-changing experience. We were just talking about the gravitational waves that you could see in the clouds. She showed me in these pictures. So I just love the full circle learning that you do at natural events like this. So thanks for having us. Over and out.
Right.
Thank you. Over and out. Thank you, guys.
Bye. Bye.
Happy Eclipse Day.
Happy Eclipse Day.
I will say for people, we're going to sign off really soon, but remember
Yep.
we have collected data. They're still analyzing the data to be done and looking at the scientific results. If you're already involved with GAVRT Solar Patrol, then stay tuned. And if you're not, you should think about getting involved with Solar Patrol.
Yep. Check us out at gavrt.org or email Miss Nancy directly at MC, which stands for Mission Control. So MC@lcer.org. We would love to work with you. And I just want to give a very special thank you to all of the many GAVRT partners that we had joining. Specifically, let's give it up for Dr. Marin Anderson there, and Dr. Belu Thangasamy, and Nancy Cruiser Jenkins, and Ryan Dorsey on the console. Of course, we couldn't do it without our lead scientist, Dr. Steve Levin. Privileged to be joined by astronaut Dan Tanney and his son, John. Melissa Poor, who is the educational director for Twiggs Space Lab. She's in the SEAS program, and her list is very long of things that she does, ERIS and many other NASA programs. And a special thank you to all of our student Eclipse ambassadors who came from all over the country. So, of course, we had Caprice, Messiah, and Natalie here in California, and their monitors were, taken great care of by students there at the ranch in Texas. So thank you to everybody. This was a really exciting day, and there's more to come. So over and out.
Bye, everyone.